Okay, thanks for that reminder. Actually, I forgot it. Let me reshare the screen again. Okay, so as for the goals, like I mentioned, so we'll first go over the serverless 101. So everyone will be in the same page. So we'll discuss about the major serverless services that we are going to use in this workshop, and also we'll have some quick look at these services at the AWS console as well, and so everyone have the familiarity, because we have a couple of, I think one guy who's just starting off with AWS Serverless. And then we will dig deep into the serverless system design. That's a major part of our workshop. And also we are going to get some hands-on experience. So like I mentioned, we are going to actually build not the entire application, but a part of the application with AWS CDK. So AWS CDK is an infrastructure as code tool, and there are many infrastructure as code tool in AWS. So we'll have a quick discussion around those tools as well, and why I chose CDK for this workshop. And then we'll further discuss about how to implement the non-functional and functional requirements of this particular application. And towards the end, or the last hour, I would like to dedicate that hour to discuss about how we can evolve our application. Because in serverless application, one of the main reason why we design serverless application architectures is for innovation. So we should be able to evolve and innovate fast. So we'll discuss about how to do that too. Okay, any questions so far? First, we can start with serverless 101. Yeah, so this serverless 101, so I will walk you through some of the main services that we are going to use. And I'm not going to cover each and every service that we will discuss today, but some of the major services. But before that, so what really is serverless, guys? So I think it's important to understand what really is serverless. I mean, like there are two major tenets of serverless. There are lots of memes, right, about serverless. Even though we call it serverless, there are servers. Of course, there are servers, but only thing is we don't have to manage or manage those servers. Like we don't have to install the operating systems, we don't have to install software, we don't have to install patches, security patches. All that administration overhead is taken care by the cloud provider. So if there is a serverless service offered by a certain cloud provider, it could be AWS, Azure, GCP, they will make sure the management of these services are done by them. So as for the customers, it's we will be actually using these services. That will take out lots of administration overhead. That's one of the major tenets in serverless service. And the other major tenet is the cost aspects of it. We will only pay for what we use. Now imagine if you spin up a virtual machine in any cloud provider. In AWS, we have EC2, right? Azure, we have a virtual machine, and GCP, we also have these virtual machines. So if you spin up a virtual machine, then as long as it's up, we have to pay for the uptime. Right? Regardless, some application is running on it, and these servers are serving the customers, customer requests. Regardless whether they are serving it or not, we have to pay for their uptime. But in serverless services, it's not the case. So we only pay for what we use. Now take example of Lambda. So Lambda is one of the serverless compute service. That's the main serverless compute service in AWS, where you can run some logic, right? So imagine if you are developing a business application, so essentially you will get requests from your users, either from web browsers or mobile applications, so on and so forth. And then you have to like run some business logic and return some response to the users, right? So in order to run this business logic, we will use AWS Lambda. So in AWS Lambda, we only have to pay for the Lambda execution time. Whenever there's a request and then that request is getting executed, let's say it takes about 20 milliseconds, you only pay for that 20 milliseconds. That's the beauty of serverless. So the cost aspects, I mean, if we compare with the EC2 machine, where we have to pay for the uptime, But with Lambda, we only pay for the execution time. That will drastically reduce your costs. So these are the two major tenets of serverless, and the other one is the elasticity. That means, let's say, take the example of S3. So S3 is another serverless service of AWS where you can store some static files, could be images, videos. You can put it into S3 bucket, right? And also we can have some HTML, CSS, JavaScript, put it into S3 bucket and enable static web hosting. That will make it a web server, right? And if you configure S3 bucket as a web server, and when you get lots of requests, let's say at the beginning you only get few requests, only few people start using it, but suddenly it get popular. So you get like hundreds of requests per second. You don't have to worry about that if you're using S3 because S3 is serverless service. And whenever it receives more requests, it will scale by itself. You don't have to worry about that. That's another major advantage of using serverless services. But make sure you remember these two things. You pay only for what you use, and you don't have to worry about managing any servers. So these are the two main things. Moving on. So I already mentioned about Lambda service. So Lambda is particularly useful to run some business logic. For any application that we develop, we have some business logic to execute. Otherwise, it would be a dumb application, right? So there are multiple services that is offered by AWS to run our business logic. Today, we are focusing on AWS Lambda. And I already briefly mentioned about EC2 instance. This is a virtual machine. So it's a virtual machine given to you. You can run your servers there. Even you can run Docker in EC2. And so this is the one. This is not a serverless service. So you have to pay for the uptime. And then we have a Elastic Beanstalk service. So this is more of a platform as a service, meaning that it's a little bit one level above than the EC2 instance. Beanstalk will provide you a platform. So, for example, you can have multiple environments for your application. Let's say you have an e-commerce application. So in this e-commerce application, you have a dev environment and also staging environment, and also you have a production environment. So with Beanstalk, you can easily create this environment, and you can easily deploy your code across these environments, and you can easily get one environment and promote it to, let's say, production and so on. And so there are lots of features built around this to make that process easy for you to handle. So Beanstalk is a platform as service. Still, it's not serverless. Behind the scene, it's running EC2. So you have to pay for the uptime of those EC2 instances. And then we have this Elastic Container Service, so the ECS. This is particularly for running containers. So we're not going to discuss further about this because we don't have much time. We have a tight agenda as well. And then we have Lightsail. So this is more like, if you want to run your WordPress application, you can easily use this Lightsail. This will give you a separate interface where you can easily manage WordPress and any other, popular content management systems. And not only that, you can run Docker. So it's pretty much similar to Beanstalk, but you can do your research on the Lightsail as well. However, we're going to discuss about AWS Lambda. So let me quickly go into AWS console and show you guys what this Lambda service looks like. So right now, let me log into one of my development accounts. By the way, in the meantime, if you have, no, unfortunately, we are not giving any participation certificate. Can't see his name. But I will make this session quite open so you guys can discuss and interrupt me at any time and ask any questions that you have. And if I know the answer, we can have a discussion around that. Or else I can point you to some resources where it might be helpful to you. Okay, so right now I am at the AWS console. So when you create an AWS account and when you first log into the AWS account, you will be directed to a dashboard like this. Okay. And then there are multiple ways that you can select search services. You can click this services and then search by the category, for example, compute, and then you can select Lambda, right? Or else you can just use this global search, which is the most common way. So I just type Lambda, and then I will click Lambda search. Or you can highlight or make it as favorite, so it will appear in this bar, so you don't have to search every time when you want to go to Lambda service. So AWS Lambda, like I mentioned, is a serverless service, and it's basically you can run some logic. And when you run the logic, you can pick whatever the runtime you want to run that logic with. So it could be Node.js, Java, Go, .NET Core, Python, Ruby. So you can pick whatever the runtime you want to run your code with, and then just add your business logic. Now today, guys, when you think about modern application development, programming language is just an option, right? It's only that traditionally only we were very concerned about what the runtime or the programming language that we're using. But with cloud, it's just an option. So you can pick whatever the comfortable programming language of yours and then start writing your code. So I'll click create function very quickly. And then you can either create a function from scratch, or you can use a blueprint. So there are multiple blueprints provided by AWS, or else you can use a container image. We are not discussing about that right now. So I'll start from scratch. I'll just say, hello, world, why not? And then I have to pick the runtime. So this is the time I will make my decision, okay, which programming or which runtime I want to use. I will use Node.js in this case. And then the architecture. So this architecture is also is important to understand, because depending upon the architecture that you choose, the Lambda's performance varies. For example, I will here choose ARM64. That will give you best good performance rather than x86 architecture. And also the cost wise also it is giving me advantage. So I'll just search, select ARM64 here. Right, and I'm not going to do any advanced settings or execution rows. So anytime when we use a AWS service, we're going to have to provide it with some permission, because all the AWS services, if it want to connect with another AWS service, it needs permission. So that's where we need to either associate some permissions through something called IAM role. We'll discuss a little bit about that as well. So when you create a role and then you can provide it permission, for example, if my Lambda functions want to send an email, then I should give the permission to email service. The email service is called SES, or simple email service. Let me see, it's not there. Simple email service. There you go. Simple email service. Or there's another one called SNS, simple notification service. Through both of these services, we can send emails and so on. So if my Lambda function want to send an email, then I should give my Lambda function permission to talk to that service. That's we do with the IAM roles. And we'll create a function. Take a second to create it. By the way, do you have any problems related to creating the AWS account? Let me know. Yeah. So once you create it, you'll get to this type of dashboard where you have the Lambda functions. And then this is the code part where you can write your code for your Lambda function. And you have some, boilerplate wrapper here. So it's basically, you can do whatever the business logic right here. You can call a database, database, and you can send email. This. Yeah, send emails. You do whatever the business logic for your application. And once you got the result, if you are sending the result as a synchronous way, so we'll also discuss about synchronous and asynchronous communication. And once you got the result, then you can send the response back to the caller. So let's see, I will click test here. So this is essentially sending some text message, hello from Lambda. So whenever this Lambda function is invoked, it will send this response. So let's quickly check that. So test event. And then I'll click test. And here we go, the response is showing here. Hello from Lambda. Now, what I did right now is I invoke from the AWS console by clicking this button. But when we are deploying this for production, we don't want people to come here and then click it. That doesn't make sense. That's where we can add trigger. Now there are multiple triggers. You can see there are a bunch of triggers that we can connect, that we can use to invoke a Lambda function. We can use API gateway. This is one of the popular options. If you want to expose and REST API, we will have an API gateway in front of Lambda function, and all our user requests will be taken by the API gateway, so all the HTTP requests, and then the API gateway can invoke the Lambda function. Or else we can have a Lambda load balance in front of it, CloudFront. So like I say, there are a bunch of services where we can invoke a Lambda function. So that's another thing I just want to give you a quick brief on. Okay, and then another thing is the configuration part of it. For a Lambda function, we can configure different metadata. One is permission, of course, like I mentioned. In order for this Lambda function to talk to another AWS service, we have to associate some permission, and that we do it through role. And so there's automatically a role created when I'm creating a Lambda function, that is this role. Now, if I click in here, that will take me to the centralized identity and access management tool or the service of AWS, which is called AWS IAM. And here, this is the role that AWS created for me for that Lambda automatically. And then I can associate permission with this. Now, here I can click add permission and I can attach a policy. And there are a bunch of policies. There are managed policies. For example, if I want to give administration permission for this particular Lambda function, so I can just search for admin, and there's this managed policy called administrate access. And when I provide this permission to a Lambda function, it can actually literally talk to all the services in AWS. But this is not a really a good practice, because this Lambda function somehow, if it was compromised, then whoever that person who compromised that Lambda function can access to any of your AWS service. So that's why the granular permission is recommended. And if you want to create a granular permission, you can create your own policy, the IAM policy, without using a managed policy. So if you want to click create your own policy, you can select create policy, and there's a visual editor also. You can easily choose the service that you want to talk to. For example, let's say I want to talk to SNS or simple notification service, so I can send an SMS from my Lambda function, and then I can give the actions. So what sort of actions that this Lambda function can do with this SMS service. I can either provide all the SMS service, all the actions, or I can handpick the actions that I really want. So likewise, you can see I can give the granular level permission to a Lambda function. Not only for the Lambda function, any AWS service, you can provide this granular level permission. That's one of the beauty of AWS platform. So we can manage our permission the way that we really want, without over provisioning or under provisioning permission. But let's close that out. And then we have a few things like environment variables. So if our Lambda functions want to talk to a DynamoDB table or a database, so I can add those values, environment variables in here basically. But the recommendation is, let's say if you are connecting to a database, could be a MongoDB or something where it has a database string. So probably we don't put that credentials in the environment directly. Other than that, we are using another couple of other two services called parameter store. So this is that service. So this is particularly developed to store parameters. Now I can put any parameters, and then once I create a parameter, I can give it a name, let's say DB string here. And then I can select whether it's a secure string. So if I select this as secure string, we can use this key management service, or this service KMS is particularly for encrypting the value. Because if we have our database string as a plain text, anyone can see it, right? But we can use one of the KMS key. Now, KMS is key management service. So this service is particularly useful for encrypting and decrypting. And then let's say this is our secret string. And then I can use my KMS key. So this is the encryption key. Now, when you're using encryption key, make sure you always create your custom KMS key. Otherwise, AWS also provides some default KMS keys. And when you have a default KMS keys, you can't really manage permission, who can access these KMS keys. We can't give granular permission to these keys as well. It would be a bit difficult, and you are strict quite a bit. So always create your own keys and then associate it with that. Just a quick side note. All right. And there's another service called Secret Manager. It's something similar to Parameter Store, but it has more permissions, or the more features around managing secret. Like we can rotate secrets, and we can give let's say some period after, let's say 90 days, the encryption keys will be changed and the keys will be rotated. So we can use that service as well if we are storing super secret information and accessing through our Lambda function. Okay, so that's about AWS Lambda really. Any questions so far, guys? We'll quickly go over this because we have some hands-on that will take some more time. So this is the Lambda service. So this is the icon of AWS Lambda. So I already mentioned about Lambda functions can be invoked by different services, right? So one of the common service that we typically use to invoke a Lambda function is called API gateway. Yeah, so there's a question from Vinay. So basically, Lambda functions can be invoked multiple ways, right? You can use another AWS service to invoke a Lambda function, just like API gateway or AppSync. AppSync is a GraphQL API. So we can use any other AWS service to invoke a Lambda function. Or else we can use AWS SDK to directly invoke a Lambda function. Now imagine you don't want any other intermediate services to invoke a Lambda function, you just want to invoke that particular Lambda function. So the best way then you can use is use AWS SDK. Now, if you just search for AWS SDK, and you have JavaScript, Python, and so on and so forth, and you can use whatever the SDK that you want to use. This is the Node.js SDK. And I'm particularly interested in the reference part of it. So you have to first install it, right? And then you can, import the Lambda from the AWS SDK /Lambda, and then you can invoke it. So you don't need any service or even HTTP request to invoke it. So you can use the Lambda SDK directly. But when you're using AWS SDK, you have to do something called SIG-V4 signing, meaning that you have to, because if you're invoking any service in AWS, you have to have permission, right? So that's where we need to associate permissions when you're invoking a Lambda function from AWS SDK. So this is called signature V4 signing. So I'll put this link in the chat. You can quickly go over that. So it's basically if you are an IAM user and you already have some permission like access keys and secret access key, you can use this permission to create some token that will be use to invoke this Lambda function. So this is signature signing. I just added a link so you can read about it. Okay, and also there's another service, another feature that they recently announced called Lambda URL, or the function URL, where each Lambda function will get its own URL. And this can be particularly useful if you are building a REST API. So just like we can use a API gateway in front of it. Now, API gateway is a fully fledged REST API service. So this has throttling, authorization, and yeah, there are lots of features baked into AWS API gateway. But you can also use Lambda URLs. They don't have like all these fancy features. Sometimes these are quite useful as well. But you can use that URL to invoke Lambda function, perform CRUD operation. And these endpoints are also highly available. So of course you can use it for production. But if you need any other additional features like throttling and usage plans, so on, then it would be better to go ahead with the API gateway as well. Right, so API gateway, I think I already discussed about what API gateway is. And if we quickly go into the AWS console and search for API gateway. API gateway, and here, by the way, the one that I just talked about is Lambda function URL. Lambda function URL. I think it's another recently announced service. And that's really good, by the way. You get a URL dedicated for your Lambda function. So whenever you have a Lambda function, you get sort of a URL associated with that. And this is a highly available URL too. You can read more about that here. Okay, so let's go on, move on. And here in the API gateway, so like I mentioned, this is a REST API. And there are REST API, with the full features, and there's a HTTP API. It doesn't have all these features of REST API, but still again, this is very cost effective. And also, whenever you have another service in between, there's always a latency, right? That's a new hope, additional hope. REST API service, or the API gateway, the fully fledged REST API has about some latency, I think about 200 or 200, 300 millisecond latency. HTTP API is like minimum latency, I think about less than 80 milliseconds. So you can use that, but it has less features than REST API. So whichever you choose, and also we have a WebSocket API, but I wouldn't recommend using this WebSocket API from API gateway. If you want to use real-time communication, have a look at AppSync or IoT Core, those services, because this is very low level. It is like very difficult to configure, and it's not scalable as well, because at the behind the scene we'll be having some Lambda functions to manage the connections and disconnections. So it's not as scalable as it is. So if you want to write a real-time API, real-time aspects for your application, always prefer AppSync. That is ideal. Yeah, so you can just go ahead and start your API. You can click build here, and then you can design your API. So it's a REST API, so you will define first the resource. Let's say you want to have a CRUD operation for users. So first you define the user resource, and then you define different methods that you're supporting. It could be post, get, put, delete. So it's a standard API basically. So I can just click new API and give it a name, users API. And then I can click create API. Look, I can now start building my API here. So I can start with a resource. So I'll just say user and then create the resource. And then I can click further into this, and then I can add the method. So if I want to get all the users, so I can create a get method. Now, whenever I create the get method, then I can pick whenever a request is received to this get endpoint, what do I want to do? Do I want to invoke a Lambda function, or do I want to talk to a different AWS service? Or let's say you have a server in your own premises, and that server is accessible from with a public URL. So in that case, you can use HTTP and give that server and URL, right? So that will API gateway will invoke your server endpoint whenever a request is received at it. Or else the most common use case that we have with when you are developing RESTful APIs, we used to go with Lambda function. And not limited to that, API Gateway is one of the services that has tremendous support for all the other AWS services. So you can pick whatever. I think most of the AWS services are available through this. So you can use the API Gateway as a proxy and forward this request to whatever the AWS service that we need. Okay, that's a strong point in API Gateway. All right. So without further ado, let's go ahead. I talk about AppSync is GraphQL API. We are not going to talk about that. Any more questions, guys? So if you have any questions, just put it in the chat in Zoom so I can easily refer to that. So this is how we connect it. So this is the traditional architecture. We call it traditional serverless architecture. And users will first connect to API Gateway, and then API Gateway, we are connecting whatever the method to invoke a certain Lambda function, it connect to that, get the response, return back to the user. So this is a very traditional way of implementing a serverless API. Right, what about databases? Now we talk about API and Lambda function that execute logic. But if you want to persist some data, then we probably should look at a database, right? So AWS databases, there are a variety of databases. NoSQL databases are there, relational databases are there, AWS native, the cloud native databases are there, or the in-memory databases are there. So there are a bunch of database choices where you can select. And the recommendation is not to stick to a one database all the time, but if your application has a variety of use cases where you can use multiple databases depending upon the purpose, always go with multiple database, right? So imagine now you are storing the data in a DynamoDB. DynamoDB is the NoSQL database, and it's one of the super fast millisecond latency database, and it can scale really well. That's a serverless database, or we call it cloud native database. This is a great engineering effort from AWS engineering teams. They build this DynamoDB, and then this can really scale very well. So this is one of the common database that we use when you are developing REST APIs or even GraphQL APIs or most of the web scale applications. And then we have this RDS, this service supporting all the other relational type of databases, let's say MySQL, SQL Server, Oracle. It supports all these other commercial databases. You can use RDS. Aurora is again a AWS specific database. It has the same MySQL queries. I mean, you can if you have a MySQL database, you can easily obtain for Aurora database. And then Aurora also have serverless edition. I mean, database wise, there are a bunch of things that you can select in AWS. So about the thing that I just mentioned about purpose-built databases, meaning that let's say your application stores some data, and but your application will have so much of queries. So then for queries, you can use a query optimized database, right? So there you can either think about Elasticsearch, right? And the Elasticsearch, there's a managed Elasticsearch service by this service called OpenSearch. And so whenever the user store the data, it will directly store in the DynamoDB. But when we are searching the data, it will use OpenSearch. So we can create architectures like whenever the data is added to the DynamoDB, we will asynchronously index that data in the OpenSearch. So all our subsequent search queries will go into the OpenSearch, and OpenSearch, since this is Elasticsearch, there is this search optimized database. So searches will be super fast. And even you can opt into some in-memory database as well. But in our workshop, we are focusing on DynamoDB. So DynamoDB, so I will use, let's say, until 10 p.m. to 10 a.m. to go over this Serverless 101, and then we'll switch over to the hands-on. So if we just search for DynamoDB, DynamoDB is the, like I mentioned, cloud-native database. So it's super fast, flexible, NoSQL data service for any scale, and it has millisecond latency. So you can, it's basically, you don't create a database, particularly you are creating tables. You can create a table, give it a name, use a table. And then there are two main things that you need to configure, or one main thing, that's a partition key, the primary key. Right? So partition key is where this data is stored. Let's say there are two things, partition key and the sort key. Now, this is the only requirement when you're creating a DynamoDB table. You have to tell what is your partition key is. Right? In this case, I will say ID, use ID. Use ID is my partition key. I can pick what is the type of that, the number, string, or binary. Always go with string, because if you choose binary, it is either yes or no, right? So how the DynamoDB works behind the scene is, when the DynamoDB table store this data, it will choose the partition, because if you think about NoSQL databases, you are horizontally dividing or horizontally separating the partitions, right? And you can scale horizontally as well. So when the data is stored, it will first check which partition does this data should be stored. If you choose binary format, it's either true, yes, true or false, right? So then, if there are lots of values in the true, this data will store in the same partition. We call it then, if there are lots of requests or the lots of data is storing in that way, that particular partition can be overloaded. We call it hot partition. So that's why typically recommended to go with string with a variety of variations. So it will spread the data in different partitions, and the load will be balanced very well. So this is a one point that you need to be thinking about when you're deciding your partition key. Or else you can also decide on a sort key as well. So essentially, if you don't define a sort key, then this user ID, whatever the partition key that you define, has to be unique across all the items that you store in the database. But if you define a sort key, let's say I will add a timestamp as my sort key, then the combination of these two has to be unique. So you can have records with the same user ID, but the combination of this has to be unique, right? And yeah, so you can decide upon your partition key and the sort key, and yeah, and this is again important. You can select the table settings. Usually, I will go ahead with the custom setting, because I can pick the capacity mode, or the read and write capacity mode. Right? That by default it's selected as provision, meaning that we can define how much ahead of the time what is the read capacity and the write capacity. But I can always opt in for on-demand as well. So if I opt in for on-demand capacity mode, whenever we get more requests, more data to be written to the DynamoDB, it will automatically scale. And there are less data to be written, then it will automatically reduce this capacity. But comparing these two options, the provision capacity, if you already know how your database is used, how much throughput it would require, go ahead with provision, because cost-wise this is optimal. This is better. On demand, a little bit pricey, but if you have web application, you don't know about how the traffic patterns, always go ahead with on demand. That is much better. And then, like any other database, you can create indexes. You can create global secondary indexes and local secondary indexes. You also prefer global secondary indexes, because local secondary indexes only define to a particular partition. And Yeah, so I'm not going to like discuss deep dive into DynamoDB. I think I have a video about DynamoDB crash course I'll share with you guys, so you guys can watch that for further information. But yeah, so like any other AWS services, encryption is provided because in AWS security is the number one thing. So you can define security at rest, encryption at rest. So whatever the data is added to the DynamoDB, it will be encrypted and then stored, right? So always obtain for encryption as well. And like I already mentioned, when you are choosing a KMS key, KMS is the key management service. So when you are selecting a KMS key, don't use the default KMS key, create your custom KMS key so you can manage the permission who has access to what. So that is you have more control over it. And then you can just create your table. No, it's a very easy interface, really, and it will take a second to create it. And once you create it, you can store data. And in order to store data, you can use a Lambda function. So let me show you. So you can use a Lambda function, and then you can use AWS SDK. And then through the AWS SDK, you can store the data in DynamoDB. Now, DynamoDB doesn't have a connection strings or anything like that. This is all operated by HTTP. So you don't get DynamoDB strings or database strings or anything to connect to DynamoDB. It's always happening through HTTP. So that's the beauty of it. And with that, we can manage the permission who can access DynamoDB very efficiently with AWS IAM. So you can associate a role, the permission to Lambda function, telling that which DynamoDB table this Lambda function can store the data or retrieve the data or whatever the actions that it can define. So you can granularly define your permission with that. Okay, so this is the typical architecture, the traditional serverless architecture that we are used to use. Any questions so far? If you have any questions, make sure you will let me know. And then the other main thing about developing a serverless application is about identities, because your application will be used by people, right? And how are you managing your people? Like how are you managing your users? So that's where one of the other serverless service comes into picture. It's called AWS Cognito. Now, Cognito is a user pool. I think some of you already know about the concepts of user pool. So in traditional applications development, if we have, let's say, one virtual machine and our service is running in there, we will also manage our users in that same server. I mean, we'll create a database table and we'll store the users there, and we'll manage the authentication authorization in that server itself. The problem with that, guys, let's say your application got really popular and you want to scale your users, right? Lots of users start using your application. So in that case, if you have the users are also managing the same server, you have to scale your entire server, right? Because you can't independently scale up and down your users. So that will like leads to waste of resources, because probably your application resources do not need to scale as much as your users needs to scale. So, but you don't have a choice. That's where it's recommended to separate users from your application. And that's where these services comes into picture. You know, Cognito is the service offered by AWS, and Azure you have AD-B2C. So likewise, we have these user stores. So Cognito, how we can like use it in our architectures is that we can associate it with multiple services. I mean, here I'm associating with the API gateway. So Cognito is not just a pool of users. I mean, we can, of course, the main primary use is to store the users in your application. But also, it can also handle authentication and authorization aspects. It's supporting industry standard protocols like O2, OpenID Connect, SAML. Let's say you want to get your users logged in with your Active Directory. So you can easily, if you have your users in Cognito user pool, you can easily connect your existing Active Directory with your user pool. There are standard integration supports. Let's say you want to help them log in with the social media, also the web identity like a Facebook or LinkedIn. You can easily connect those third-party web identities with Cognito through OpenID Connect or to standard protocols. So this is a very standardized service, and it supports lots of standard authentication and authorization protocols. So here, when you're using the API gateway, whenever the user is trying to access a particular endpoint, let's say they want to get all the nodes, right? Let's say we are storing the nodes or the to-dos. We are storing to-dos in a DynamoDB table, and people want to get their to-dos only. So in that case, if one user want to try to hack this system and get another one's to-dos, if you don't have any authorization logics going on, they can actually do that. I mean, if you are using a user ID, and if you know about the other person's user ID, and if you have a method that accepts the user ID, and that Lambda function will use that user ID to get the to-dos and return to the user. If you don't have any authorization logic, then they can actually hack the system, right? That's where we can use Cognito user pool to include some authorization aspects. So when the user try to access the Lambda function and the data through the Lambda function, there will always be a check whether this guy can actually access what he needs. So there are multiple ways that we can set the authorization. There's a Cognito user pool authorization, and there are some custom authorization we can also build upon. We'll discuss a little bit more about that in our workshop. So we only have 2 minutes for this segment, so let me quickly go into other slides as well. So right now, these are all mostly synchronous, right? What do I mean by synchronous? So when a user wants to get some data, API gateway will call the Lambda function, then Lambda function will call the database, wait to get the result, and then return to the API gateway and send it back to the user. Synchronous architectures look simple, but there are lots of repercussions. Like, if there's a lot time-consuming logic in the Lambda function, then the users have to wait until whatever that logic is executed. They have to wait, right? As users, we don't like to wait, and that is hitting that's sort of disturbing the user experience. And so that's where we prefer synchronous processing or asynchronous architectures, because actually if you think about the world is asynchronous in nature. If you go to a restaurant and all that, if you order some food, the way whoever wait the table do not like stare at your face until you make the order, right? He will just provide you the menu and he will go away and serve another customer. And once you are ready ready to order, he will come back and then get your order and then give it to the chef or give it to the whoever cooking the meal, and again go and serve another customer. Likewise, the real world itself is asynchronous, and that will really improve the the parallel execution process. It will improve that aspects of it, and people don't have to wait until one thing is completed. There are no dependencies in asynchronous architectures. So that's why we prefer asynchronous architectures, because asynchronous architectures is really a requirement if you want to build a scalable application architecture. So that's why I want to dedicate these few slides about asynchronous processing. So there are services like SNS. I already discussed about this service. So you can use this service to, I think you might be familiar about this particular pattern, publisher-subscriber pattern. Publish-subscribe patterns. Basically, you can publish some information to SNS topic, and then you can have multiple subscribers that are interested to fetch that information. So take the example of you're making the book order from an e-commerce website, right? And once the book order is made in the backend, you can have this type of SNS service, or there's another service called EventBridge. These services are particularly supporting this publisher-subscriber pattern. So once the book order is made, of course, the book order needs to be processed. So one subscriber will be interested in processing that order, and you can have another subscriber who will actually update whatever the user just bought in their recommendation engine or something, because analytics is important. So that's main purpose is to update the analytics part of it. So likewise, you can have multiple subscribers who are interested in a certain events. For that, we can use SNS service. And so this is like publisher subscriber. And then also we can use a queue. Right? Queue is mostly about point-to-point communication. So if you put some item into a queue, and then you can have another consumer that will consume these messages. So why do we need queue in the first place? Because these queues are managed serverless services, and they will scale independently. And now, let's say now we have a use case in our application that we are going to develop, where lots of people want to let's say register for this fuel application, the fuel pass application that we are going to discuss. But there's a verification process where there's a third-party system is there, but that is built with a on-premises server and doesn't have much scalability built into it. But when you receive like 1,000 or million requests at once, that backend servers cannot stand that, right? Because it's not scalable. So that's where we put a queue in between. The queue will scale, queue will absorb all these messages, but we will have a consumer, it will consume these messages in a manageable throughput to the backend services. So we'll use a queue to separate or decouple these two entities. And so our application architecture or our backend servers are not going to fail, or they are not going to go offline because due to high throughput scenarios. That's one of the use case, the load balancing aspects of it. And there's this DynamoDB stream, like I already mentioned. If you are building purposeful or the purpose, if you're using multiple databases, like in the previously I discussed about, you will write to DynamoDB and you read from OpenSearch or Elasticsearch. How you can set up that architecture in an event-driven manner, because in asynchronous architecture, we prefer event-driven computing, meaning that when an item is added to the DynamoDB, then there's an event is triggered. Okay, something, this item got added. Then we can do something about that. Okay, if the item is added, then index that item in the Elasticsearch index. It's very event-driven. So no one is waiting until its indexing is complete. DynamoDB doesn't care about it. It only says, okay, this item got added to me. Here's that information about that item. Anyone can, whoever interested can do whatever about it. Right? So that's where we will use another Lambda function also to capture that event. And that event will include the payload, and we'll get that payload and index into Elasticsearch. Likewise, asynchronous architectures really make our life easy, particularly if you are building highly scalable architectures. Right, so this is the same example I just mentioned. Yeah, over time though, but once the item is added, so up to this part is synchronous, right? The Lambda will wait until the response is returned, and then it will return it to the user. It's the to-do example, right? But after that, Lambda will, DynamoDB will tell, okay, there's something added, here's the stream, here's the event, and then whoever the interested parties can consume them and then update it. Yeah, here's another example with SNS. So SNS can have multiple subscribers, and we're actually going to use SMS part of it. So once we can have we can use SMS subscriber, I can tell, to send a message to the customer end user, or we can use email service or another Lambda functions. Likewise, if you have a Lambda function, you can do whatever you want, right? So it's very flexible in nature. SQSQ, I already mentioned about that. All right, finally, before we, there are two services I want to just touch based on this. Because in most of the applications that we develop, we have to store some images, videos, and it's these static files, right? So that's where there's another serverless service called Amazon S3. I think this is the cheapest service that you can find it in the market, like even across cloud providers as well. S3 is very cheap. So you can search for S3, and this is the scalable storage in the cloud, and this is object storage. Object storage means that you can't put a database in here, right? Database need this block storage. But if it is a, let's say, some static files and you want to serve it to your customers, then you can put it in a S3 bucket. And let's say now databases, sometimes we don't store really large data, right? Blobs of data. So if it is a really large file, what we usually do is we put it to a S3 bucket and then have a reference, the path to that particular bucket, the metadata of it stored in a database or the DynamoDB table. That's a common pattern as well. So for your static file requirements to store this static file, we'll use S3 bucket. And the other main use case is when you create S3 bucket, there's an option that we can convert this bucket to act as a static website. So this is a bucket that was created. So if you go to this management section of it, that's not the management, I think it's properties. Yeah, in the properties, we have something called static web hosting. So by default, it's not enabled, but you can enable it. If you enable it, then this will act as a server. So you can put your JavaScript file, HTML files, CSS files, because at the end of the day, browsers can only read JavaScript, HTML, and CSS, right? So whatever the front-end framework that you use, library that you use, React, Vue, Angular, ultimately when you build the application, it will be HTML, CSS, and JavaScript. And you can get that build file and put it into S3 bucket, enable static web hosting. There you go, you have a web server. And this is scalable web server as well. That's another very useful use case for AWS. All right, and finally, I would like to talk about when you are serving this static file, what we usually use is a CDN service. CDN is a content delivery network. Content delivery network, one of the serverless content delivery network is CloudFront. So CloudFront is a content delivery service. So this is operating at something called edge location. Now, whenever, let's say we create a S3 bucket to store our static files, images or so, we have to pick a region. Region in AWS, there are different regions. We have region in US, we have region in Europe, we have region in Middle East, India, Australia, China, different places. And as for the compliance requirements, AWS will make sure when you select a region, let's say in this case, if I select one of the US region, let's say Oregon or North Virginia, if I pick that particular region and put some images into this S3 bucket, these images will never go out of that particular region. That is for the compliance reasons. But on the other hand, when we're accessing that particular image from Sri Lanka, the request has to travel a long way, right? Because it's a long way for North Virginia from Sri Lanka. But if you have a CloudFront, so the round trip time is long, so thereby the latency is increased. But if you have a CloudFront in front of it, the CloudFront operates at something called edge location. Edge locations are also small, medium to small data centers. And we have so many edge locations in AWS compared to regions. So we have edge locations in close to Sri Lanka, we have edge location in Mumbai, right? So the very first time when we access the request, it will check whether the information is available, the cached, or that particular image is cached in the edge location closest to our place, let's say in Mumbai, whether it's cached in that edge location. If not, it will first get the file from the US or the North Virginia and take it back to the CloudFront and store it in Mumbai edge location or the data center and then serve it to the user. Next time another user try to access it, it will first check whether it's available in the cache. If it's already available in the cache, it will serve from the cache. So that round trip time will be saved and the performance will improve. That's one of the main use cases of a CloudFront. The other one is that it acts as a reverse proxy, meaning that you can use this as a proxy, just like we are using API gateway to proxy with Lambda and other services. You can use CloudFront also as a proxy. You can have S3 bucket, API gateway, load balancers, anything that you can, like most of these things you can proxy, even if you have on-prem server, and that on-prem server can be accessed through HTTP or the using a URL, you can even proxy your on-prem server as well, right? So what does that give us? Then there's only one single point of one entry, right? This is a single entry. And when you have single entry, you can associate all your security related services at the CloudFront level. The service called AWS WAF or the Web Application Firewall, you can configure that WAF at the CloudFront level. So regardless, your on-prem server do not have any sort of security built around it. If you have CloudFront in front of it and you have associate WAF, then you will get that security advantage. So WAF will also filter out any web vulnerabilities related to layer 7, like DDoS attacks. No, I think, yeah, DDoS also. There's a protection with CloudFront, and any other top 10 OS vulnerabilities like cross-site scripting, CSFR. There are lots of managed rules that we can configure with WAF and associated with CloudFront. That's a really good architecture, by the way, and we will show you in details how we can connect. All right, so that's about it, and now we have created all the AWS services, but ultimately we need to consume that service from a front-end application. It could be React or it could be Angular, Vue, whatever the application framework or front-end application framework that we use, we need to consume these resources. So one of the ways that we can securely consume these backend resources is to use this service called AWS Amplify. Now Amplify is a framework, I would say. So it has a couple of tools. We just search for Amplify framework rather. So it's mainly there are 3 or 4 components to it. Amplify libraries. Now these are, it has JavaScript library, Android, iOS, React Native. So depending upon your client, you can find a library for that. This library is particularly useful to connect to your backend resources securely. Now, previously I mentioned about SIGV for signing and shared some links with you as well. So if you want to do that by yourself, then there's a process to it. You have to write the code to do the signing process and all that. But this Amplify library manages that for you. Like SIGV for signing is automatically done for you. And on top of that, let's imagine you have a front-end application that is built with React or Angular or Vue. When the users sign in, and I told you, we already discussed about Cognito, right? When the users log in with Cognito, then the Cognito will send you the tokens, right? You will get the ID token, access tokens, these tokens that we commonly use for token-based authorization. And Amplify, it will manage this token for you. What do I mean by managing? These tokens are short-lived. That's the whole purpose of making these tokens short-lived, because if a token is leaked out, and if it is a long-lived token, then anyone can use that token to access your backend resources. So the advice is not to have long-lived token, have a short lifespan token, like 1 hour or even less than that. But the problem with that is then we have to refresh it every time once that token is expired. Amplify, this will do the refreshing behind the scene for us. You don't have to worry about it. One less worry, and actually that's a really good advantage. Otherwise, we have to check whether the tokens are expired. Otherwise, when your users are working on your application, they will suddenly logged out. That's a very bad user experience. But Amplify will do that for you. And then you have the Amplify CLI. It's essentially used to provision the resource at the backend, which I don't usually recommend to use. One reason is there's lots of abstractions to it. So, I mean, it would be really useful if you want to get application up and running in the shortest speed of time. But if you are really developing a production application, then it's not a one-time development, right? You have to do the maintenance, the new guys joining in your project and so on and so forth. But because of these lots of abstractions, and in fact, there's a prompt-based resource provisioning, meaning that you get the question, it will ask the questions, and you have to answer the questions, and then with your answers, it will configure your resources. But whenever there's a new CLI version, the version is upgraded, these questions changes. So it's not very, how do I put it? It's not I wouldn't recommend it for production applications, but if you want to get a POC up and running quite fast, of course, go ahead with that. Instead, you can either use CDK, which we are going to use in this session, and or you can use serverless framework, SAM, all these things, because then they are like you can manage your resources much better with more control, really. Yeah. Okay, then we have Studio and Amplify hosting. This is basically hosting is for like deploying application, and we are again doing that with CDK. Amplify Studio is a visual, low code, no code sort of a development platform. Again, really good for your POC and get something up and running quite fast. But in our case, we are going to use Amplify library for very good reasons. But we will deploy, provision all our resources using AWS CDK. Any questions so far? Okay, good. Right, so we will have our Amplify library with the front end, and the front end then it will communicate with the resources that we provision through CDK. So secure way. So there are multiple ways we can deploy our resource. CDK is one of the options, and we are going to use that. We briefly discussed about serverless framework. This is one of the very first library, I would say, the framework, I would say, to deploy provision resource on AWS. Even today also, I'm using it in some of the projects. It has a very good plugin ecosystem, and there's very good community support as well. So if I'm doing a production project, I will either go for CDK or serverless framework. SAM I haven't used much, but I think serverless framework, they have lots of plugins, community builds plugins, as well as serverless framework build plugin as well. Okay. So CDK is a cloud development kit. So it's basically when you're writing code, we use object-oriented concepts, and we have a class and we create objects out of it. We have inheritance, interfaces, all these things that we usually use with code to write our business logic. We can use the same principle to provision our infrastructure. That's the beauty of it, right? So developers will find it as home, like it's pretty much. For example, have a look at this. We are creating S3 bucket here, right? So we new an S3 bucket, and this is the scope we pass into it, the logical name, and few required attributes. That's all you need to create S3 bucket, and then you can associate your, let's say, build file. Let's say you are using React also. You will use that npm run build. When you run that, you will get the build file, CSS, JavaScript, HTML. You will put it in a, let's say, build directory also, and then you will point it to that place. So that that S3 bucket will take it the sources, so the files from there, and then when you do CDK deploy, you will have a S3 bucket. You will have a S3 bucket with static web hosting enabled with this amount of code actually. We'll have a look. All right, so 20 minutes late really, but just sort of like going over that, since we have several guys who are beginners to AWS Serverless. Okay. Any questions so far before we move into the next section? So when you're going into the next section, I'd like to take you to this particular GitHub repo where I've created a part of the application that we are going to develop. And I added several branches, step 1, step 2, step 3 through 5, where I can easily pick the step and then like walk you through with the code. And in the meantime, you can also follow along and practice it on the go. I'll give some time to try out as well. So we are going to start with step number 1. I'll share this in the chat. By now, I hope everyone has an AWS account created, and also Node.js and AWS CLI installed. Right, let's get started on this, guys. So let's see, in about 30 30 minutes or so, we'll have a quick break, a 5 minutes break or so. But so this application that you're going to develop, like I mentioned, we're going to develop one part of the National Fuel Pass application. If I just, if you're from Sri Lanka, you already know about it. But if you're from a different country, you might not know about it. So this is the application that was announced, introduced sometimes back, a few months back. It's basically you can register your vehicle, right? So if you haven't registered, you can come here and give your mobile number, and then it's basically you're logging with your mobile number, right? That's the one part we are going to explore how to do that with Cognito, OTP-based authentication. And once you log in, then you get to store your user information and then store that information as well, like the first name, last name, address, NIC, and you can store that. Once you do that, then you will get to the vehicle details, where you have to register your vehicle details. What is the the number plate, the vehicle number, and you have to chassis number, and like so, and also the type of the vehicle is the car, van, and yeah, so those information needs to be registered. So that's where it will do the verification, right? Because anyone can add anything, right? I have this car and this is mine. Anyone can do that, but it needs to verify that. And that's where it will go ahead and it will talk to a third-party database or the system just to verify this information, whether your information that you provided is authentic or not. Right? So we are going to implement the logging part as a hands-on, and I will also explain how to do the rest of it, so you guys can take it from there, because otherwise we have to do this the entire day. So in the login process, right, I think most of these services now we are aware about it, because that's one of the main reason I went over this Serverless 101 section, where we discuss about CloudFront, S3, Amplify Library, Cognito, API Gateway, Lambda, DynamoDB, SNS. So these services, you already know about it. And let's see how these services connect with each other. That's the important part that we are going to discuss. And in the vehicle registration, we'll go about discussing about the asynchronous architectures, how they really scale the systems. Because one of the things that really happened just after this was launched, people started registering from everywhere, like so many people, and maybe 1,000, 2,000 people in parallel try to register their vehicles. But system couldn't tolerate that, because like I mentioned, there's this third-party system that it is depending upon to verify the information that the users are adding. This is not scalable, right? And because of that, things failed. The very first day that was launched, it didn't go through. But then again, the team really got that fixed very soon. But it's not built with serverless. But I wanted to show you, if you are building such system with AWS Serverless services, how would you go about thinking doing that? At least thinking about the architecture. So that's why I wanted to have a discussions towards the end how you can scale this architecture. But before that, we are going to get some hands-on with the user registration part of it. Yeah. Any questions? All good? Okay. Right. Okay. So here, what we are going to do is we have users, and we are using CloudFront. And why we use CloudFront is as a proxy as well as a CDN, and we can associate security aspects as well. We can configure a WAF here. I'm not doing right now. And then we will have our application, which is our web application. We will create it with React, and then we'll build the files and we'll put it into S3 bucket, and we'll enable static web hosting. So that CloudFront will direct all the user requests to that static web application. And once the web application is in the browser loaded the web application, Then in the web application, we have Amplify library. Amplify library will then start with the user registration part of it. We have to register the user. So we are adding the users in the Cognito, and then we are using this OTP-based authentication process. By the way, guys, this OTP-based, the passwordless authentication is not directly supported by Cognito. That's something you should think about when you're using Cognito, because if you think about other competitor services like Auth0, right? Auth0, if you compare Auth0 with Cognito, Auth0s are like, I would say, 50 or 100 years ahead of Cognito, right? There are so many services built around Auth0. I mean, if you want to, if your application is like heavily depending upon so many features about authentication, then it would actually make sense to go with Auth0. But the problem with Auth0, no problem. But compared to Cognito, with Auth0, there are two main things that you should consider. Cognito is an AWS service, so it is like tightly integrated with other AWS services like API gateway, direct integrations are there. AppSync, if you have a GraphQL API, you have group-based authorization automatically built with Cognito, which otherwise you have to build them by yourself if you are using a third-party identity provider like Auth0. So, on the other hand, Cognito is cheap, right? Compared to Auth0, it's like several times cheaper than Auth0. So it's again depending upon your requirements. So I would start with Cognito, and if I see any limitations with the features and all that, then I will probably link Auth0 as a third-party identity provider with Cognito, right? So I'm not like completely getting rid of Cognito. I will have it as another third-party association, so I can get the best of both worlds. I can get the all the features from Auth0, and also I can get the other benefits from the Cognito. Okay, so this custom authentication flow, because what we are right now doing is custom authentication, because we are allowing users to log in with their phone number. We don't ask them to enter their password, right? That is not the standard login authentication process that Cognito support. So we are doing a little bit of a process, a little bit of work here to enable this phone number authentication process. And that's where we are going to use some Cognito triggers. Now, whenever a user is registering with a Cognito, there are certain Lambda functions, depending upon the life cycle, that can be triggered. For example, when a user is signing up, before the signing up is complete, we can invoke a Lambda function, right? These are like life cycle based Lambda function. And when a user is logging, before Cognito generates the token, we can invoke another Lambda function. So likewise, I quickly show you because this is important. If you go to Cognito service, there are multiple triggers. We call it Cognito triggers. I'll quickly go to Cognito service. I think I didn't show you Cognito previously. This is the Cognito service, how it looks like. I don't have any user pools created right now. So I just can create a temp test one and review defaults, create a user pool with the default settings. So when you create the default user pool, now this is the user pool I just created. Right now I don't have any users in it, but I want you to focus on this part, which is the triggers. Now here, we have a bunch of triggers. We have pre-sign up, pre-authentication, post-authentication, post-confirmation, define auth challenge, create auth challenge, verify auth response, user migration, pre-token generation, like so. There are many triggers that Cognito can use to invoke Lambda function. So we are going to use some of these triggers to accomplish our purpose. So since this is a custom authentication flow, it's always based on a challenge. Now, I think you already know about this. If you are supposed to, let's say, log in, then you will enter your phone number, and then you will present it with a challenge. So what is the challenge? So whoever the authorization identity provider will send a SMS with an OTP, like a code to your phone number, just to make sure that phone number is actually belongs to you, or it will send an email to your email address with a token with the code. or else it could be a link where you can click the link and then you're authenticated. Now there are lots of modern authentication flow. So in order to support this modern authentication flow, it's all about defining a challenge. This challenge could be sending an OTP, sending a magic link, where the link, once you click the link, you're authenticated. Or else, I mean, it could be a series of things. It could be like multi-factor challenges. First, you have to enter the OTP, and then you will be sent. It will send an email with your email address is authentic, and then again you can define another challenge. Likewise, you can change these challenges as well. So we are not going to change the challenges. We are just using this OTP, where when the users enter their phone number, we will send an SMS with the OTP. To do that, to do this custom authentication flow, there are three trigger functions we need to use. One is defining the auth challenge. We need to define what is the auth challenge that we are presenting to the users. And then we need to create that auth challenge. And then we need to verify the auth challenge. Whatever the user enter, let's say, as the OTP, we need to check whether is that the correct OTP. So these are the three main Lambda functions that we are using. And apart from that, we are also going to use another trigger, which is called pre-authentication. This is actually mitigating the limitation that Cognito has, where it doesn't support passwordless authentication. We are going to use this pre-authentication trigger. We will automatically verify the user through this trigger. So if their OTP is correct, then Cognito will still ask for the password. So we are basically skipping that process. We'll say here, all right, if that guy's OTP is correct, then we'll automatically verify that guy. So these are the 4 triggers that we are going to use, and that's what I have added here. And the create auth challenge. So this is basically, we need to send an SMS to the user with the OTP, right? So that's why we are using this SMS, or the simple notification service that we are using to send an SMS to. Okay, so let's get started. And we'll discuss this flow as well. So once the authentication is complete, by the way, once the user is properly authenticated, so what happens is the Cognito is returning the tokens, because we have to return the tokens if you're using token-based authentication, ID token, access token. And then Amplify Library will use this token to communicate with our backend resources. Because what we are going to accomplish is, once the users are properly signed in, they need to store their information, like the first name, last name, address, and they need to store it. So we have to make sure that the users are already authenticated and they are authentic users. That's where we are going to use API Gateway, and we will have Cognito to verify whether these users are already authenticated. So there we are going to use this Cognito authorizer. Right? We'll get to that, but before that, we need to complete the first part of it, and then we'll start creating a DynamoDB table. Because maybe some of you may be wondering, why do we need to create a user table? Aren't we storing all the users' information in the Cognito? No, that is not something that we usually do. We will store the bare minimum information for authentication in the Cognito user pool. Why? The reason is, if we add any domain-specific information in the Cognito, then it would be hard to expand or hard to innovate your application going forward. Now imagine you want to connect some third-party applications going forward. You have to enable single sign-on, so on and so forth. But if you have like tightly coupled attributes in the Cognito, it would be difficult. So what we do is we'll make sure the Cognito will have the bare minimum information to log in and authorize the user, and any additional user information related to his user profile information, some application specific information, we'll put it in a user table separately. So that's why that's another design decisions that we typically use when you're building SaaS application, guys. All right, so enough of me talking. So let's get to it. So you can go here. All right, where is it? Okay. Yeah, I think I already put it in the chat. So here, I think you should start following the README, right? So these are the prerequisites that we have right now. So I believe you all have an AWS account and Node.js installed, AWS CLI version installed. I have links if you haven't already done that. And then you can configure those access keys and the secret access keys of an IAM user that you create. Now, if you haven't created, by the way, if you saw this part, so right now I don't use identity access management service directly. I'm using another service called AWS SSO, Single Sign-On or Identity Center. Now they have recently renamed that service. This is actually much better than IAM, because if you are in the AWS and if you go to this IAM service, this is the place where we'll create our users, right? Right now, I have 2 users. Now, if I go to the users section, now I can, this is, I think, something that you should also do once you have an AWS account. You go to this IAM service, search IAM, and then go into this service, and then you click add user. You can give it a name, just Manoj, and I can give how this user is accessing the resources. So here, if you want this user to log in to your management console, this particular this particular AWS console, you can give this one. But if you only want to access via CLI, give this one, only programmatic access. Right now, we want this user to access only programmatically. You pick that and then you select the permission, right? So this is the place we will associate either managed policies, or you can create your own policies with the granular access. Probably for this example, you can select the administrator access since you are using multiple AWS services. You can later fine tune it and click next tags. You can give it a tag. This is useful for determining what this user had done, and also there are some attribute-based access control patterns as well, but we are not going to use it though. And then we'll review it, and then we create the user. So when you create the user, then what you are presented with is access key ID and the secret access key, right? You can click show and copy both of these access key and the secret access key, and then you can configure it in your local machine 2 ways, right? I'll show you both 2 ways. One is you can add it at as the environment variable. So here, depending upon your OS, I'm using Mac OS, so I can just use export and then access key ID and the value that I just added, they copied. So you will use these 2 lines: export AWS access key ID and export AWS secret access key, and put it in the environment. You can do it in your terminal if you're using Mac. You can just take a terminal session and then just copy it and then paste it and hit enter, then you are good to go, right? If you're using Windows, similarly, you can use set in that case, set AWS key, and then configure it. PowerShell, of course, this one, right? So this is one of the ways where you can set this credential at the environment. And this is much better, I believe, because the other option is you can put it in a file, and this file is .aws file. This is in the home directory of macOS, and if you're using Windows, this is in C users folder. It's a .aws. There's a .aws folder. You can create it, and then you can create a file called credentials, and then you can associate. You can copy paste this information in there. The problem with the IAM approach is, guys, of course, I think you can do it for this demo or this workshop. These are long-term, right? Now I added administrator permission, right? And if you store it in your local machine using this file credential, then if someone steal your data credential, then they can have unlimited access to your AWS resources. Since we give administrator access, they can do whatever really, right? But right now what I'm using is AWS SSO, where these credentials are temporary. I can set the expiration time, how long these credentials are available. Usually, let's say if you are working with a team, it's advisable to use this particular identity manager or AWS SSO, because typically you have multiple AWS accounts. Right now I have 3 AWS accounts, and this is my master account or the main account, or the very first account that I sign up for, and that's the master account or the management account we call it. We don't usually put any resources in there, right? You already always create other AWS account through something called AWS organization. So in your AWS account, you can click here, and there's this service called AWS organization where you can create as many AWS accounts as you want. So you don't have to enter your credit card information or anything. You only have to edit your add the credit card to your very first account that you create, which is your AWS, which is your management account. The subsequent account that you create, you don't have to enter any credit card information. You only have to have different email addresses, and then you can go ahead and create it. And then it's best practice to create multiple AWS account for your projects or different environment, dev prod staging environment, and have your resources in there. There are various advantages to that. There's a video I also created around that as well. Probably I'll share that with you. But for now, you go ahead and create an IAM user and then copy these credentials. Either choose, set it at the environment or put it in the .aws file in the credential file. Right? Go ahead and do that, guys. So once you are done, okay, give me 1 second. You can copy that, or else I'll use this one really. Copy it, and I'll use a terminal. That's my terminal. Okay, just use a separate terminal. I'll take a terminal, and then you can use command prompt if you're on Windows. Just paste it. So if you create an IAM user, then you only have 2 things. Export the AWS key ID and the secret ID. But if you're using SSO, there's another one called session token as well. But this is not required if you are creating an IAM user. Just hit enter, that's all. Now I can verify whether it's properly connected, AWS S3LS. So this is a command line command to list out all my S3 bucket. Now it shows up. That means I can access my AWS resources through CLI. That's the very first thing that you need to do, guys. And then go ahead and follow along and let me know you're done with the first step. So step 1, I will put this. I just copy this part and I'll put it here. So once you're done with the step 1, just you can thumbs up this comment, I believe. So when I get a few thumbs up, we'll move to the next one. All right. Okay, we already have 1 guy already done. So let's see if we get a few more thumbs up, we can move on. So what we're essentially doing is, I'll also quickly show what we are doing here. So here, you guys can follow the README, but I will use some Git branching magic. Git status. Yeah, so I'm on Git branch step 1. So what we essentially have here is, I don't have any CDK stuff here, although this folder is empty really. What I have is a React application, right? So we use create React app. Let me quickly walk over to what we are doing, right? We're using create React app, and we use npx command to create a React app using create React app helper library. And then we'll install Bootstrap as well. So we have some styling going on. And I will also use install React Toastify to my Toast messages. And that will install first. And then once this create React app is created, its boilerplated code, then I will see my code structure like this. I have a source folder and I can go into it, and there's this app.js file and index.js file, standard two files that we usually have in a React application. And then I'll go into this index.js file, and then you can just copy this one and then put it in there. So index.js, here we go. So it's nothing much. It's only reference in the Bootstrap and the Bootstrap.js. That's it, basically. And the rest is already available through the boilerplate. And then next, you can create app.css file. There's only one CSS file I'm adding. So there's this app.css. So there's this form signing. I just add a max width. And then source app.js. In the app.js file, you can just come here and just click this button and then paste it in. Basically, this will give a basic few forms, and these forms will be enabled and disabled based on certain states, right? If there's no user is logged in and there's no any sessions, it will show this particular form. This form is essentially, Okay. So this form is essentially showing the login form, and then he can initiate this login with phone number flow, right? When you do that, there will be a session created because Cognito will create a custom auth flow session. But still again, user haven't yet confirmed or they provided a response to the challenge. Like we are expecting them to add the verification OTP. So still the user is not created. So that's why I'm adding if the user is not yet created, but all right. But if you have any questions, feel free to unmute and ask. Yes, so the session is created by the Cognito, but the user is still not verified, so the user is still not created. And the last form is, now the user has confirmed it and everything is success. So this form will capture the user information, like the name, address, NIC, and so on and so forth. And each form, we have on submit handlers. So I have defined those handler methods up here. So you have sign in, verify token. This is a sign in. So right now it's a tab, just some console login, verify token, and the save user details. And we'll add that information going forward, and also sign out button. All right. So then at the end of this step one, and also make sure you will copy the whole thing app.js and then replace everything in the source file app.js. And finally, you can go into this called pass folder or whatever the folder that you added, and then you can do a npm run start, and maybe there's anything related to AWS right now, just a React application. Yeah, so I can just do npm run start. Oh. All right, it's a very simple UI. So you will see the personal details, vehicle, and sign out. And let's see our Toastify is also working properly. Although this doesn't do anything, just a message showing up, right? We haven't connected it with anything yet. So you can type the phone number and get the OTP. So what we are essentially doing is when we click get OTP, what we are going to do is, this is that sign up process, because that's the registration. We are only letting users to add their phone number and sign up. So there will be a request initiated by Amplify library. It will go to the Cognito, and then Cognito will return with the challenges. So that's where, as for the next challenge, they are supposed to enter the OTP. and then it will verify it. Once it is verified, the tokens will be sent to the user or the browser. The browser will store that in the local storage, and that tokens will be subsequently used to connect with the other resources, particularly to store the user information. That's what we are going to accomplish in this hands-on. Any questions, guys? So let's see how many people. Did only one guy has done it yet? Yeah, about 21 participants. But feel free to ask any questions or anything that you have right now. I don't think all 24 is in this Zoom. Yeah, anyway. Okay. Right, okay. I'll give you guys a few more minutes. Okay, 2 people are done. So we'll wait one more guy to complete, and then we'll move to the next step. And in the meantime, if you have any question, feel free to ask. Okay, let's go to the step number 2. So you can select step number 2 in the repo. So now this is all about provisioning CloudFront and S3 with the runtime code. Now we have a React application right now, and then we can actually build the React application in npm run build, and that will spit out excuse me, HTML, CSS, SS, and JavaScript. Then what we are going to do, we'll get that code and put it to S3 bucket and serve that S3 bucket through CloudFront. So let's see how to do that with CDK. Now CDK, I think already gave an introduction about CDK. So you guys can start following the steps right now. So essentially we are first installing CDK CLI. So there's a CLI, and particularly we're using this version number 2. But here I added the specific version because if someone has a different version, and it would be difficult to troubleshoot in a call as well. So use this version for now, and the TypeScript version as well. So we are using the same versions, at least for this workshop. So if you're on Mac, if you need permission, you can use sudo, or if you just if you just want to, if you're on Windows, I think the same PM command will also goes through without an issue. Yeah, so if we first install CDK, and also we'll install TypeScript CLI because we are using the TypeScript version of CDK. The CDK, it supports multiple languages. Right now, I think you guys can see the reference document for CDK. I will put it in the chat as well. Yeah, this I think one of the very useful resource when you are writing your CDK code, right? Here you can go to API reference. Oh, even before that, you can see I can pick the language I'm using: Python, JavaScript, .NET, Go. By default, it's switching to the TypeScript version of it, and make sure you are using CDK version 2 something, right? The version 1 is now, they are no longer supported. You can click API reference. Okay, you can go to the developer guide as well if you are completely new to CDK. But essentially, I think this is very straightforward, right? So here what we need to do, first we need to initiate a CDK project. Now that's why we are going to create a folder called CDK. Let me switch into the code editor, top the server a little bit, and I'll, yeah, okay. I'll switch to the second one, Git checkout. Step number 2. Okay, so here in the folder plus application, the folder, you have to create a new folder called CDK. Now, because when you're initiating a CDK project, this folder has to be empty. Right? Otherwise, you will see an error thrown by the CDK CLI. So make sure you create an empty folder called CDK, and that's what we are suggesting you to do that here. So create a directory called CDK and change into that directory. And then you will initiate a CDK project, CDK init app, and make sure you select the TypeScript language. You can select other language if you are comfortable with others, but we'll use TypeScript here. When you do that, what we are presented is sort of this boilerplate code, right? And there are a few things I want you to pay attention to. One is this bin folder, and this is the main file, I would say. This is the very first file when you do CDK deploy. Now there are different commands. Okay. Now in CDK, there are different commands, guys, right? So in order to deploy something, we will use CDK deploy. Right? And this, what we'll do is it will first go ahead and check the main file, which is inside bin, and that file is cdk.ts file, right? So this is where we are going to define our stacks. Now in CDK, there's something called stacks. Now stacks are something corresponding to CloudFormation stacks. Now in AWS, the main infrastructure as code tool is called CloudFormation, right? Even CDK, ultimately, whatever the resource that we provision through the methods, like S3, CloudFormation, CloudFront, and whatever the method that we are going to use to provision these resources, ultimately convert to CloudFormation. And the CloudFormation service then pick up that CloudFormation template. And CloudFormation templates are in JSON or YAML. And then CloudFormation service, I think let me quickly show you just for the completeness. There's this service called CloudFormation. CloudFormation. There we go. This is the main infrastructure as code tool. I mean, of course, we don't need to use CDK, Amplify, CLI, SAM, or any other helper infrastructure as tool. If you can just purely write CloudFormation template. But the problem with that is you have to write so much code, so much configuration. Right? That's why we are using these helper libraries or the helper projects to finally convert those convert into this CloudFormation template. We don't have to then specify each and every line for CloudFormation. That is helpful for the developers. Yeah. So, but however, ultimately it's using this CloudFormation, and it will deploy to AWS. Basically, it will provision resources from the CloudFormation. Okay. You create a stack. You will see I can have an existing template. I can upload a template, or I can give a S3 URL with a template URL and click next and then deploy that CloudFormation. So CDK will, what it does, it will create a CloudFormation template and use CloudFormation service to deploy that. So that's essentially what it's going to do. And CDK, there are three things we call CDK constructs. Right? There's something called level 1 construct. Probably should not put that one in front of it. And then level 2 constructs and level 3 constructs. Level 3 constructs, right? So level 1 constructs are direct representation of CloudFormation. So if you are to write provision a resource through CloudFormation, and if there are some attributes that you need to specify, let's say when you're creating a S3 bucket with CloudFormation, I'll show you what does that mean. CloudFormation S3. To do that, then this is what is required to define S3 bucket. Now look, I need to define all this information. I will show you the YAML version of it. And I have to define the type of this and then the properties. Now this is the YAML version. So you have to define all these things. And there are some required attributes. If you just search, yes, this is a trick I use. So there's no required attributes for S3 bucket, by the way. That's good. So if you just use yes, type yes, then it will point me to the required attributes. However, so level 1 is direct representation of CloudFormation. So you have to specify everything that is related to the CloudFormation required attributes. Level 2 is one level above it. A good example is in the S3, we have another one. We again search for S3. We have another one called S3 deployment. Now, this is not just S3 bucket, but this will again like enable static web hosting as well. So this is actually what we are going to use. So we want to use this higher level constructs so that it will make our life easy to provision these resources. Still, now these are highly configurable as well, right? That's why I prefer over Amplify CLI, because in Amplify CLI, only way that you can configure these resources is through editing the CloudFormation. And then again, it's a little bit difficult as well. But with CDK, it's quite easy to customize these even level 2 constructs. That's a level 2 one, right? So what about level 3? So these are a little bit higher level constructs which have some abstraction. And level 3 are essentially patterns. CDK constructs hub, constructs.dev. So this is a place where you can easily find out level 3 construct, right? And even you can create a level 3 construct and publish it. Now, the beauty of CDK is you can create your custom construct and publish, so the others can also use it. And if you go to serverless land, there's another website called serverless land, and this is another place where you can find out these patterns, right? There we go. So you have like so many patterns. Now look, and here you can pick the tool infrastructure as code tool. So if you want to load balancer and a Lambda service created, then you can just directly use this pattern. And this is published by AWS. I think. You can just click view the pattern, and you can clone this pattern and you can deploy it like so. So this is the level 3 construct, guys. Okay. So yeah, so if you want to like create an event bridge and event bridge destination, they don't have CDK related constructs. But yeah, here we go. There's another pattern with Lambda connecting to event bridge, and it connects to the Lambda. Yeah, however, I will just share these links with you, but we'll get to our workshop. Otherwise, we are running late. Okay. So go ahead and create that, guys. And then I showed you the bin folder is the very first folder, the very first stack that when the CDK deploy is looking at. So this stack is how I like divert into all that is. I was telling now this stack is sort of corresponding to CloudFormation stack. Right? When you're developing your production application, you can have one stack. I mean, there's no problem. But mind you, guys, if you are like developing let's say an application with so many connected components and so on and so forth, there's always a CloudFormation hard limit with 500 resource limit, right? Meaning that you can have up to maximum of 500 resources provisioned through CloudFormation. That's a hard limit, and you can't increase it with support ticket to anything. So in that case, it's good. You will first observe your application and the things that could grow, things that could scale, and the things that you could innovate in the future, and sort of create separate CloudFormation stack. Don't do it overly, but make sure that you are doing it as a sensible decision, right? With a sensible decision. However, for us, like it's not much, so we'll just use one CDK stack. And here, I can deploy to multiple environments as well. If you don't specify anything related to environment, let's say I can, if you have a dev environment, I can define, okay, the account that I'm deploying to, I will take it from the environment variable from wherever the CI/CD pipeline I'm calling this CDK deploy, right? The region. So you can set it at the CI/CD platform environment, and then it will pick the account and also the region that is going to deploy. Or also you can hard code it as well and tell what is the account ID and this one. If you don't specify anything, it is like account agnostic, right? It's not tied to any account. You can deploy it like we are going to do with whatever the connected AWS account, and you can deploy it anywhere you want. That's more like account agnostic, AWS account agnostic. However, this is the first start. And the next file that is referencing is in the lib folder called CDK stack.js. So that is our main stack information that we are adding here. So right now I have added all my resources in this file itself. But usually if you are building a production application, you should create resource-oriented, like a resource-based stacks. For example, you should have a stack, the resource stack for S3. So all your S3 buckets will be in it. And you can have a Lambda stack, you can have a DynamoDB stack, so on and so forth. But for this workshop, we'll have everything in one file because it's easy. Otherwise, we have to navigate back and forth with the application files. And when you're doing that, you can use all the programming constructs like interfaces, so inheritance, all that good stuff that we do with object-oriented principles, design and all that is possible. As you see, we have constructors, you can pass in interfaces, you can create your own custom interfaces, you can create your custom constructs, like so. But that's a little bit advanced for this one, this workshop. So here what we're doing is we're essentially creating a S3 bucket and we're using that S3 deployment. So this is the level 2 construct that we are going to use, bucket deployment. And if you follow along, you should see how we have done it. So first we are using creating S3 bucket. And when you're creating S3 bucket, we will give it a logical name. And then we will tell where is our index.html file, right? And whether this is publicly can be read. So here I enable true, but you can disable it and then use CloudFront to access that using something called origin access identity, OAI. But let's keep it simple, guys. So I'll make it publicly accessible. And then here, I'm not just defining my infrastructure, right? Of course, I need S3 bucket. Of course, I need to enable all these static web hosting, all the configuration. But in the same time, I would need to get my code related to the S3 bucket, related to my website stored in the S3 bucket. Where do I get the code? It's basically from my React application because we are going to host our React application in S3. So in the React application, if I go to package.json, here we have this build command, npm run build, then that is going to build it, and that is going to create a build directory. So inside this build directory, I get the static files, images, all that JavaScript and CSS file. So what I'm right now doing is, I'm telling this CDK deployment construct, all right, as the sources, take it from the build directory. See. Now, do you see the beauty of this? So I'm defining my infrastructure together with my runtime code. So that's really how we, the CDK is quite beneficial. So now you can version control your infrastructure. That's really good. So that's the one benefit you get with CDK. And there are other tools like Pulumi that does the same thing. But if you are like infrastructures are mostly in the AWS, I would recommend CDK for this. Right, and then not only that, now what we are going to do is we are going to create this S3 bucket, and also we are going to serve it through CloudFront. So in the same code, we are creating a CloudFront distribution. Again, we are using this new construct. If you want to find out whatever the construct, you can go to the CDK reference I just gave you. Just search for CloudFront. Here we go. Click it and click Overview. And then you will get all the examples on how to create a CloudFront S3 bucket. You see S3 bucket and expose it via CloudFront. You get all these good documentation. Or in fact, now imagine you want to know what are the other attributes in the CloudFront distribution I can configure. So you can easily use code complete, right? If you click Command or Control and then click Distribution, then you will get to this definition files. You will see everything that you can configure it. I'll show you another one. Here we go. So here I can define the options. Now here there's an option called default behavior. I don't know what do I like add here. So if I don't know about it, I can just control click it, and then I will see information about that one. Okay, this is a default behavior and that's of type default behavior option. And don't know about that, I can again click into this one. All right, so the default behavior action is something related to the origin. So if I want to know about origin, I can further click into that. I can like drill into the information that I want to configure, like it says 3 origin, right? It's like self-documenting. That's a good part of using a programming language. So you can drill in and find out the required information that we need to specify, right? Okay. I think in the meantime, I've got a question. When you go to CDK provision, just curious, whatever the resources we provision through PDA after completing with the project, do we just need to delete the CF and start? No. Resources, so CDK take care of anything else. Yeah, so I just told about only one command right now. It's CDK deploy, but there are other commands. So if you want to delete the entire stack, which I did before this session, so CDK deploys is basically it will right now we have written it in the TypeScript. And so let's imagine now we wrote our infrastructure in Python, right? CDK use TypeScript, right? So TypeScript engine is there, right? It will ultimately convert to the TypeScript, and from TypeScript it will convert to a CloudFormation. That's how it happens. So there's another command called CDK ls, right? Or synth that will give me the CloudFormation the representation of my CDK code. Now I'll quickly show you guys. So what I want to come to the point is there's another command called CDK destroy. So this command will completely destroy our stack. Now, when you're destroying, a couple of things I want you to think about. Let's say you create a resource, let's say S3 bucket, right? Or DynamoDB table. Then I can define the deletion policy. There's a one called retain on delete. So right now I don't know what it's expecting. So I can just click here. Oh, it's a Boolean. That's good. So I can go back. I can just say true. Okay. So if I set this, then if I delete it, then this S3 bucket will not be deleted. Likewise, you can set the deletion policy, particularly for your data storage, because data is important, right? Because if you have a database, DynamoDB table, and if you do CDK destroy and delete your data as well, probably that is not what is your intention. So you can retain the stuff that you don't want to delete, and the rest of it will automatically delete for you. But that is something I just want to point out. However, you can use this CDK destroy command. There are other commands like CDK bootstrap. I think in this example, I'm asking you to do the CDK bootstrapping. What happened? Yeah, here you go. And step number C, you need to do CDK bootstrap. So when you do CDK bootstrap, so what happens is it will configure your CDK with your AWS account. Because in order to deploy CDK stack, there are certain IAM roles and some stuff that is required by CDK. So that deployment infrastructure it will create with the CDK bootstrap as well. So make sure you follow along, otherwise you'll probably get errors if you don't do CDK bootstrap properly. And then finally you do CDK deploy, and that will deploy your stuff to AWS. And let me do that and get back to the questions after that. Right now I'm at okay, step number 2. Yeah, and I think configure the terminal session. There you go. I configured it in a different terminal session. So Okay. CDK and CDK deploy. You see, first it's going to synthesize it, right? So what does synthesizing mean is it will convert our stuff to CloudFormation. Now then, when you're doing CDK deploy, uh, it requires your permission. It requires your permission right here because it's going to create some IAM related resources like IAM roles and so on. So you need to give your permission because in AWS, security is one of the core things. So you have to give your permission. This is actually what you're intending to do, right? If not, if you think about, okay, these are too much permission, of course you can find in. So that's a good way to verify stuff and click yes, and then start deploying, right? One thing I just want to quickly show before I get to the questions is that there's a folder called CDK out, and that will contain all my CloudFormation related templates. So this is my final CloudFormation template. Now in the CDK TS, how many lines are like only up to 40 lines here. But here we have like 500 lines of CloudFormation, I think. I mean, just imagine how we make that CDK, like make our life easy in that case. And the best part is like you can configure if you want to do any customization with CDK. Okay, there are a few questions. Okay, I discussed that. Cold start. Okay, cold start, two things. Yeah, so I think he has given the answers as well. So I think the recommended way from AWS to prevent cold start is this provision concurrency. The old way that we have been doing is we were tapping the Lambda function, invoking the Lambda function time to time, like every 5 minutes or so, we'll invoke the Lambda function. So the cold start right now, what they're recommending is to use provision concurrency. But still, again, if you use provision concurrency, the Lambda cost model is getting changed because provision concurrency, what essentially does is it will keep some execution environment open all the time. And that is going to involve some cost apart from the execution cost because Lambdas are usually built for the execution time. But with the provision concurrency, it changes, right? So you have to pay additionally. And if you do it without thinking much, you will end up with a huge bill, right? So be careful about it. But on the other hand, now they are doing lots of innovation to reduce the provision, so the cold start as much as possible, right, guys? So because that's something AWS is actively working on, reducing the cost. I think this reInvent, they have released one of the thing called, I think, Stack. I can't remember its name. It's basically for Java functions using Java language. The cold start is like minimizing quite a lot, right? But even for the other programming languages, they are doing the innovation. And one suggestion I would like to tell you guys is one of the recommendation for me, always try to avoid this glue code. Now, for example, let me quickly show you what I mean. Because Lambda should be used to use for the transforming request, not for transporting, right? This is something to think about, right? Now here, have a look at this. Right? API gateway wants, like, now we get a request to, let's say, store some data about a user, right? And what we are doing is we have a Lambda function here, and then with that Lambda function we store that data. I mean, it would be. I mean, it makes sense to use a Lambda function if you are doing some transformation of the payload that we receive from the API gateway body. And if you want to do, let's say, do some business logic operations and then enrich the context and the data before saving, it makes sense to have a Lambda function. That's basically the reason for using a Lambda function. Otherwise, if it is just get the data and put it in the user table, we might as well not use Lambda and then use something called service proxy integration. directly we are storing it in user table, DynamoDB table. And this doesn't, then there's nothing called cold start. Cold start is not a problem at all, because there's no any cold start with direct integration. But the challenge here is these service integrations are essentially done with templating language called VTL, or the velocity templating language, right? So it's a different VTL, Apache velocity templating. So it's not like a difficult, but you need to learn a little bit about how to write if then else logic, for loop, so on and so forth. It's a little bit some learning curve involved in it. For example, let's say to write a so this is how you set a variable in velocity templating, and like so, right? But if it is like a small thing, you can of course use velocity templating language, and it's quite straightforward. I mean, you can understand it. But if you have loops, nested loops and loops, then might as well use Lambda function in that case. That's my recommendation. Yeah. However, now if you are using AppSync for GraphQL, now they have given us a feature recently where you can write JavaScript for for service-to-service integration, which is really cool. So you don't have to learn much about VTL templating. But still, unfortunately for API Gateway, although it has like so many service can be connected through that, we have to do it with VTL. But it's not hard for a simple integration, but if it is a difficult integration, I would also recommend just to go with the user registration lambda. Sorry, whatever the lambda in between. Okay, so that's my opinion on that. So in the meantime, how are we doing with the okay. Only one guy completed it, or any issues in that? Okay, we have more messages. Recently, yeah, Snapchat. That's what I'm talking about, yes. Yeah. So again, I think this is serverless framework, like it's tested over time. I think this is one of the very first framework, like I mentioned, that was introduced. And there's so much of a community support there, and there are lots of plugin developed as well. So this is, I think, even today also I would use serverless framework because it has like lots of community support in that case. CDK, on the other hand, right now also it's getting very popular because serverless framework, although there are lots of plugin to it, if there's not a plugin, if there's some service that was recently introduced, you would have to wait for some time to get a plugin either from community source plugin or serverless framework itself. They'll come up with a plugin, so you have to wait a little bit, right? And in the meantime, if you want to still use it, you have to use CloudFormation because serverless framework supports CloudFormation as well. However, even with plugins or anything, plugins will introduce some abstraction, just like level 2, level 3 constructs in CDK. But still, again, it's not programming language, right? You have to use YAML. So if you want to really take the benefits of a programming language, all the loops, the interfaces, and really write your infrastructure as code adhering to object-oriented concept, then it's good to go ahead with CDK because the developers are also familiar with that, because when you're making a decision, you always have to think about the familiarity of your development team. You can, of course, introduce things like CDK TF, CDK for Terraform, right? Terraform, again, is a popular choice for infrastructure development, deployment. And CDK, not recently, a few months ago, they released the CDK for Terraform version. Essentially, when you do the CDK deploy, it's not converting to the CloudFormation, it's converting to the Terraform understandable JSON. And then you can use that Terraform in the Terraform cloud, and you can use Sential and all that to associate different permissions, the policies that you typically use with traditional Terraform modules. That's another thing. So, I mean, there are lots of options, but when you're picking an option, always think about the familiarity of the development team, how is it that they can grasp it, because that's something very important. Yeah, so I would actually use either framework or CDK. Because both are like really good tools for infrastructure as a code tool. All right, I think we can move on, right? Let me know if there's any issues, because I actually put together this code yesterday night. Probably there are some issues related to the code. So let me know, I can always fix that. Okay. Moving on, so it's 11:33. Shall we take a quick break, guys? Let me see, about a 5 minutes break or so, because it's been some time we have been doing. So let's take a quick break, and during the break, you can actually go over the third step. If in the repository, you can select step number 3, where we are going to provision user pool and the Lambda triggers. So this is interesting. So you guys can either have a quick break. So right now it's 11:34, 35, I'll tell you. So we'll meet again in 5 minutes. So we'll resume the workshop at 11:40. Yeah, I think we can continue with step 3, but in the meantime, probably be running a little bit short with the time, but let's see, we'll not rush through as well. Okay, so in this step number 3, we are actually provisioning the user pool. Hopefully, you guys can hear me. Can you hear me? Hello?
Yes.
Okay, great. Yeah, so in this step, we are going to go ahead and provision our user pool. So we are going to provision the user pool and the triggers. Essentially, we are doing it 2 steps. First, we'll create the resources, and then we'll create the Lambda functions, and then we'll associate the runtime code of this Lambda function, because in each Lambda function, we have to have a runtime code, right? So we have to have a logic to define those challenge, create those challenge, and call the SNS service to send SMS to the user and verify those challenge, and then and also automatically verifying the user's password as well, because like I mentioned, there's a shortcoming. There's a that feature is not yet supported by Cognito, so I have to do some work around here with the pre-sign up Lambda trigger. So here, I think you guys can continue on that. So here we are first using this user pool construct. You can go to the construct library or the reference here, and then search for user pool. Okay, is that okay? I'm in a different room. Cognito, I think. Okay, yeah, I had to select Cognito. So what we're using is level 2 construct of Cognito, and we're using this one, right? Essentially, we would give it a name, and then let me see what are the things that we have configured here. About going back and forth. Here we go. Yeah. So we'll enable self sign up, so anyone can sign up by themselves. So if you have application that you don't want to enable it, you can make it false, and then you can use Cognito admin APIs to get a user registered. So there are places that we don't want people to self sign up, right? So you want to handle it by admin. So here you can, in that case, turn it off. But in our case, that's fine. And then signing alias. So this is where we are going to use the phone instead of email and password. So we'll set it to phone, and the standard attribute will set the phone number, and we'll make it required. And then we have to make it mutable as well. Because in case like if a person sort of changes their phone number, we should have a way to, through the admin panel, we should have a way to update the phone number as well. So that's why we make it mutable. And then So this is the user pool part of it. I think this is only the required attribute. The rest of it, you'll get some sensible defaults. Because if you think about the CloudFormation, there are lots of things that we have to provision, but these are the stuff that we want in our application, for our application. The rest is the default, like the password, strength, and how are we communicating with the users. Those things we are using defaults. And then we need to configure a web client. Now, user pool is one thing, but one user pool can be consumed by many clients. Imagine now you have a user pool with the users, and that you are using, you have a website and you have a multiple mobile application, but still you want to have your users in a one centralized place. That's where you will have one user pool, but you have multiple clients that is working or communicating with that user pool. That's why we need to create a user pool client here. So again, I'm adding a client, can give it a name, and then this is very important. We have to set this custom auth flow to true. Otherwise, it will just stick to username password on this flow. You have to do that. And then, yeah, and then let me see. So we have to go to status. All right, here we go. So here what we do is the one I just described. So we add the CloudFront, not the CloudFront really. Okay, here we go. The user pool, and I haven't yet defined the Lambda triggers, and also I'm creating a user pool web client. Right? So these two are important, and then we need to define the Lambda triggers, and I think you can find out in the step number 2, where you have to add the Lambda triggers, and we'll update it. So in the user pool, we have another option to define the Lambda triggers. So essentially, we'll say, okay, the define auth challenge. What is the Lambda corresponding Lambda function? Create auth challenge of the corresponding Lambda function, so on and so forth. And there we will add the references of the Lambda functions we define up here. So define auth Lambda function, if I command click it, then it's pointing to a Node.js Lambda function. Now, this is also a level 2 construct, guys. So this is particularly for the Node.js function. So this level 2 construct will take care of transpiling the code. Now you can write it in TypeScript, and you can use so it's basically transpiling stuff, and it take care of most of that aspects as well. So that's why I'm using one of the level 2 construct, so I don't have to separately transpile my runtime code, because CDK will do the transpiling for the infrastructure as code, but if you're adding a runtime code, I need to like transpile it, right? So this one, it will automatically does it for me. Node.js function. And so here the same thing. So I have to point out where my Lambda function code is, just like I pointed out where my S3 files were in the build file. So right now, I have actually created a folder called functions right here. So in that function folder, I have created several folders, each one containing a one Lambda function. Right? Create auth challenge, and it has this handler.ts file. And as with any other Lambda function, you have a handler code. This is the entry code for the Lambda function. This is what's getting executed when this Lambda function is executed. And so I think the first one that we need to check is the define auth. This is the very first Lambda function. So this is the place we are defining the auth challenge. So we are defining a custom challenge, right? And we will actually do that. And if you are not familiar how to do this, you can actually get some example from AWS itself. So if we just search for AWS custom auth flow, you should see the examples right away. You can copy paste most of the code and optimize it to the way that you want. So this is the workflow. It goes through the take you through the custom auth flow. When the initiate auth request is initiated to the user pool, meaning that someone want to register, very first Lambda function is this define node challenge will invoke, and then it's creating the challenge and sending back to the user, and then Cognito user pool will create the session in the user pool itself, and then it will invoke the create or challenge Lambda function, which is actually creating the channel. I'll show you what it is, otherwise it will be a little bit difficult to understand. So, so here, this is the defining part of it. Because like when you create a user in the user pool, or when a user try to sign up, we have a Cognito session, right? So here what we are essentially checking, we have a couple of if-else blocks, and in the if-else blocks, we'll essentially defining, okay, if there's no any challenge defined, make it a custom challenge, right? And then in the create or challenge, this is the place where we will send that OTP code to the user, and we need to create that OTP code in the first place, right? That's why I'm using math.random to generate OTP code, and then I'll get the phone number. Now this is important, by the way, because we are asking user to enter his phone number in the form, right? So how do we access that? So in that information is available in the request user attributes in the phone number, and you can access that phone number from there. And then after you get the phone number, we will use SNS, simple notification service. And in SNS, we have this publish method. In the publish method, we can send a SMS basically. So here you need to define some message, your OTP, and the answer, the OTP that we just calculated up here, math.random value, and then the phone number that we want to send that one to, and the message structure, some attributes related to the message, right? And make sure it's a transactional message, because there are two types of SMS, promotional and transactional. So you can define it as a transactional SMS, and that's it. So then you will send the publish it. So it will get to the user's phone, and after that, once we get the OTP and add the OTP value, then we need to verify whether it's correct, right? That's what this verify or challenge responds to. The user will send some answer. So we'll capture it with event.request. Whatever the answer he adds, and we'll check whether it's equals to the challenge answer, right? The one that we have within the session. If it is so, answer is correct. So then he is authenticated. So then he will get the tokens. So let me quickly show you again. So once the verification is answer is okay, and then Cognito will generate the tokens, ID tokens, and access token, and send it to the browser. So since we are using Amplify, once we get the browser tokens, ID token, access token, it will automatically add it to the local storage. We can choose whether it's the cookies or the local storage that we want to use. Either way, it will stay in the browser. And for the subsequent requests, those tokens will be used. Any questions? Because I just run through it quickly since we're a little bit running out of time. Okay. So you guys can go ahead and start with it. And I added the steps as well. So you can just copy paste and then do it. And yeah, one more thing. Now here in the create or challenge, we need to call SNS, right? So in order to call another AWS service, we have to use AWS SDK. That's where we are requiring this AWS SDK up top here. Right? However, in the I think not the latest Node.js runtime, but I think in the 14, 12, 14, 16 even, they have this the previous generation of AWS SDK, right? And we don't have to like particularly install AWS SDK as a dependency together with the Lambda function and bundle it, because it's available in the runtime itself. That's why we have a way to tell that using CDK, Node.js level 2 construct. If you scroll up here a little bit, there we go. In the create or challenge, we'll specify when you're bundling the Lambda function, skip any external modules. We don't actually need it because this is already available. And if you already have, let's say, another modules available through Lambda layers or anything, because you have your separate Lambda layers for logging or like a separate database connectivity and all that, you can add your own custom modules. If I have a separate login layer, I can skip it because it's already available via Lambda layer. So likewise, there are options since we are using this Node.js level 2 construct. Okay, and then what we do here is finally we will add the runtime code and the Lambda functions infrastructure. Again, both of them are created, and this is an interesting one again. Now that the create Lambda function has to call the SNS, we need to give the permission to that Lambda function. Like I mentioned previously, if one service want to communicate to another service, we always have to grant the permission. So that's why we have another policy statement defined, SNS publish policy. So we will allow to publish to SNS, and then we'll associate it with the create auth Lambda function role. You see, I'm using this create auth Lambda, and I'm accessing the IAM role and attaching that as an inline policy. So our Lambda function is able to make this request, this particular request. Otherwise, it's unable to do that. You will get an error with 401 resource cannot be accessed. And those are the highlights for that part of. There's one more thing. You need to install this ES build as a dev dependency. Otherwise, this Node.js Lambda, the level 2 construct, it needs to do the bundling part of it. So it's going to use local Docker, right? You need to install Docker. And that's going to take some time to bundle the stuff and then do the deployment. Hence, it's good to use this ES build dev dependency. The bundling will be quite fast. So make sure you install that one as well. And then finally, you can do npm run deploy. By the way, I couldn't tell about this npm script I actually created here, because that is created for a few reasons. Now, in the code structure, under the full pass, the main directory in the package JSON, I've added two scripts, right? So if I do npm run deploy, it will first build the React application using React script build, and then cd into the CDK folder in here, and then convert any TypeScript code with TSC to JavaScript, and then I will do the CDK deploy. So I don't have to like separately go into the CDK folder and deploy. So when I have it available via package JSON script, I can use this in any CI/CD pipeline as well. It could be GitHub Actions, or it could be code pipeline, or any other CI/CD tool that you guys are using, Circle CI or whatever really. You guys can access these scripts, right? And then I again use the post deploy. Now this is a convention. If you have a deploy script, you can have pre-deploy and post-deploy. So what happens is if you run a command npm run deploy, it will first run the pre-deploy, then the deploy script, and then the post-deploy script. So I don't have a pre-deploy because I don't want to do any other dependencies or I don't have any other dependencies to build. I will do the deploy, and then it will execute the post-deploy, where it is going to create a CloudFront invalidation, because we are now, we could be changing the front-end code, right? And we'll be storing it in the S3 bucket. Now here, these are like common things that we do in whatever the application that we develop, right? So we put it in the S3 bucket. But since we have CloudFront in front of it, we have some caching going on, right? So even if the new code is added to the S3, CloudFront will be served with the cache. So that's why we're explicitly doing a CloudFront invalidation in the post build script. So we can do AWS CloudFront create invalidation, then the distribution ID. Make sure you will update the correct distribution ID as well. and we are invalidating stuff. So we'll get the latest stuff whenever we do a npm run deploy. So let's go ahead and do that. In fact, I hope you guys are also working on it. Okay, I have to deploy it from my other terminal. This way I configured my environment variable. Go one step before and then npm run deploy. I have to update the CloudFront distribution ID in the post deploy, because in the previous step, in the step 2, we provision our CloudFront and the S3 bucket. And by the way, one other thing I just want to quickly show you guys. In the CDK, we can spit out any outputs that is useful to us. For example, in the CDK, lib stack ts, at the end, I'm putting out some CFN outputs. So here, CloudFront ID, CloudFront domain, or anything actually, I can take it out from these variables. For example, if I want to get the user pool client ID, I can spit it out as well. So when the deployment is complete, these things will be available. So I don't have to go into the AWS console and then find out this stuff. Yeah, let's see. I'll quickly show you that aspects as well. Are there any questions so far? All good? I'll show you. I'll go into the AWS and show the resources that has provision, since we have multiple resources getting provision right now. Yeah. Okay, now I think this will not work. There you go. Because there's no CloudFront distribution with this ID, because this is one of my previous IDs. So here, but I can actually, I spit out this information from my Cloud CDK itself. I can really update it. I'll just copy this one and I'll go to package.json and then update this value. All right. Now, if I do another deployment, it should be succeeded, and I can actually let me run it, and then I'll show you the resources that it has provision. I'll do another npm run deploy, and while it's going through, I'll quickly go to AWS and show the resources that it had provision. Now, if I refresh this CloudFormation, then I should see the CDK stack. Now, ultimately, it's using CloudFormation, like I mentioned, to deploy stuff. So right now we should have a CloudFront distribution, because in the step number 2, we provision a CloudFront and S3. So if I go to CloudFront right here, here we go. We have this CloudFront distribution. Nice. And in fact, we have created a link, right? So the CloudFront is connecting to S3. How does that link set up? Through something called CloudFront origin. We have defined S3 origin. Now we can see we have connected our S3 bucket. Now it's it's a weird name, it's a long name. This is because we didn't give a specific name to the S3 bucket, right? If you want to give a specific name, you can give it, but you have to make sure when you are giving a name to S3 bucket, it has to be unique, right? Since anyway, we are using these resources, destroy and redeploy anytime, I'd also prefer this without giving a specific name as well, because we need to use as much as from CDK. So we don't want to make sure the bucket names are unique, all that stuff. Don't want to worry about that. So here, if I just click on, so it's pointing to the S3 origin. Now let's see if this bucket is available. I'll just copy this part of it and I'll go to S3. So then I will see that S3 bucket also. Yeah, I'll just here we go. We have S3 bucket and it's giving me a warning it's a public, right? Usually it's not usually we go ahead with public bucket. We probably have CloudFront only CloudFront to access this S3 bucket. So only the CloudFront can access. You do that with origin access identity, but I don't want to like go over that right now. Can easily find out if you search for CloudFront OAI. Here we go. We have a build file from from React. And if I go to the properties, then I should see my static web hosting is also enabled because I enabled it through this CloudFormation through the CDK. Look, I have the static web hosting enabled too. So you can see now we have this one provisioned properly. And now I should see a Cognito user pool as well, because in the step 3, we provision a Cognito user pool. You can quickly check that too, Cognito. And here we go. Manage user pool. And there we go. This is the one I test, the created one, just for the Serverless 101. But this is the one that created through CDK. Now here, if you look at it, you can see the phone number is our the required attribute. The username attribute is also set to phone number. And this thing we didn't define, right? The minimum password length. These are like by default, the sensible default from CDK. So, and this one we particularly define whether the users can sign up themselves. The other stuff, like mostly we didn't define. One thing I want to show you is, if I go to triggers now, I should see my trigger setup as well. See, the pre-sign up trigger is now properly set up to this particular Lambda function. And the define auth is set up. Verify auth is response is also set up. And the create auth is also set up. Perfect. By the way, this is also really a useful trigger. If you're particularly moving over to Cognito from your traditional database, let's say you have users right now with your application on SQL Server or MySQL, then you can use this user migration trigger. So essentially what it does is something additional, but very useful. Essentially, if you have a Lambda function connected here, it will first check whether the user is available in the user pool. If not, this it will execute whatever is called. So here we can actually call into your existing database and do the verification and return a true, like assertion to the assertion through this Lambda function. And then what happens is that user will automatically get created in the Cognito. Next time, that assertion will not, I mean, it's not going to go over and connect to the existing database. It will take it from user pool. Likewise, you can step by step, in a sequential manner, you can migrate your users flawlessly as well. But however, if you use Auth0 or something like the latest things, you can migrate your users directly from identity provider. But unfortunately, in Cognito, you can't export your users. You can't get their password because, and that's a security good feature. But yet again, like when you want to move your users from your existing user stores to Cognito, that's a problem. So we have to use something like this. All right, I think we went over most of it. By the way, I think you guys must have already work on that one. This is about Cognito and Lambda. Yeah, make sure you just thumbs up that. Okay, let's see. This time it went through. I ran the CloudFormation as well. Now CloudFront invalidation, it ran through. So now, if you scroll a little bit up, I should see my CloudFront domain. Now, if I just copy this one and then take it to a new browser tab. Why is that? Okay. Right here, and I paste it, hit enter. There we go. We have our application serving through CloudFront. Right. And let's try out. By the way, if you have a new AWS account, right now when you type a phone number and get the OTP, SNS needs to send an SMS to your phone number, right? But when you have to enable it to use it in the production, right now it's in the sandbox environment. So before trying this out, you have to go to SNS, right? And validate or verify your phone number. You don't have to do this when it is on production though, but right away, I mean, you go to SNS, search for SNS, I think you guys have seen it. SNS, Simple Notification Service, come here and then click on this little bar and go to text messaging. And you need to add your phone number, right? This is required because right now we are in the sandbox environment. If you are ready for the production, then you have to send a support request to AWS, and then they will take you out of the sandbox environment. Then you don't have like verify stuff. So I have already verified my SMS. They're essentially sending an OTP again, and then I have to like verify it. And now let's see. Hopefully, I should get an SMS, and then I should go through the process. Let's see. Now let's check +94. Okay, this is my phone number. Let me just preserve logs as well. OTP. I think I didn't set up the front end code. Oh yeah. So I need to update the handler code right now. I don't think it's not attached right now. Let me quickly see. Right now I'm in level step 3. So if you go to source and the app.js, you see nothing's not connected. So I'll just quickly replace the file. Okay. I'll probably go to step number 4. So let's go to step number 4. Status. There you go. Now I have the stuff ready. Now here, in step number 4, is also important, guys, because that is something commonly we are using. Like I mentioned, we are using Amplify library to securely communicate with our backend, right? So if you go to step number 4, I hope you guys are done with this step. This is all about manually configuring our front end with the stuff that we configured in the using CDK. So here in the front end, we have to install Amplify. This is the library, right? This is a JavaScript library. So if you have like Android, you have an Android version of it, and iOS and React Native, right? So this is supported in many clients. And here I need to update the index.js file. So this is the place we are manually configuring Amplify. Now, if I go to the index.js, here we go, index.js. Now, previously I only had this part, but now I am manually configuring amplify.configure. From where do I get the Amplify? It's from the AWS Amplify library. So I just import it here and I do amplify configure, and then I can configure my auth because we are authenticating part of it, right? We are authenticating with the user pool. I have to add the region user pool ID. Now this is from the previous example I've been testing it with. But now I need to go to AWS console, or else I could have like just spit out in the CloudFormation as output. But let's go to here. So it's good. Yeah, I just go here, and then I'll just get the user pool ID, and then I'll configure it here. You have to add the user pool ID and the user pool web client. Now I mentioned already about the client. We can have multiple clients, and we already created a client. You can find it in the app client section. There we go. This is the client ID that is required. So I can just copy it, and then I can configure it here. That's it basically. So mandatory sign is true. So everyone, people need to sign in properly. That's all. So I think with this, we should be able to log in, and I'll do a deployment one more time. npm run deploy. And let's see if I need to give any permission. No, I think it's all good. Yeah, it's getting deployed, right? Okay, and give it a second. And in the meantime, we'll quickly go what else is we are doing. And in the AppJS, like I mentioned, okay, now there's the other thing. So I use Amplify in the index.js to do the manual configuration here, right? And I use the same AWS Amplify in the AppJS. And here I'm getting auth module. This auth module is where we are going to use it for signing. So when the user clicks sign in or the get OTP, we have a method called auth.signing. And we are passing the phone number that is getting from the form field. And then we are going to set the session. So I have like a couple of use states or some variables defined here where it will set some sessions. Now these are like standard React stuff, use states, and also use effect here I'm using to just to verify whether the user is authenticated when very first time, every time this component is getting loaded. So here I'm again using another method in the auth module, auth.current authenticated user. Now you might be wondering, where do I get to know about this stuff? So that's very easy because you can just go with Amplify docs and go in here and select Amplify library because that's what we are using, and select the JavaScript. You have Flutter, React Native, Swift, Android as well. And go to authentication part of it, getting started. And this will talk about how to use Amplify CLI to add authentication. That's where, like I told you about, it's asking questions and you have to give the answers and can like change, can deprecate it quite easily. And, modification is also a little bit difficult. That's where we are using this one, create or reuse existing backend. So there's another separate document to it. And here it will tell you about how to reuse existing authentication resource. And this is exactly what we just did. We imported Amplify and we are doing Amplify configure and manually configuring our auth. All right. And then if you want to use auth, you can click sign up, sign in, then how the code is going to look like. So we have example, good documentation really. So how does the sign up and how does the signing, forget password method should go like. So you can just read through this and then like most of these examples can be used and tweak a little bit fitting to your use case. All right. Any questions? Okay, what happened now? Didn't I? Okay. I think I didn't save the previous one. Okay, because I switched to the step number 3, but I forgot to update this one. So that's fine. I don't need any CloudFormation invalidation, but if I try to do a hard refresh here. Okay, let's see if it's still giving me that. No, I think it's not updated properly. So this time what I will do is, instead of running all these things, I will only run this script. So I will just use this one, copy. I'll go to my terminal and I'll only run this one. That will do only the invalidation part of it. Okay, it's complete, or at least in progress. But it won't take much time to do the invalidation. So if I do a refresh, there you go. I made the toast and all that. And +9 let's see. There we go. Oh, yeah. So there's a one error message. This is basically the user is not available right now. And let me see if I get a message. Because very first time a user is trying to log in, it's not available. And I got the message. So yeah, I got the OTP. That is 9558115. I wanted to show you one more thing, because once this customer challenge goes through, it's going to send me the tokens, right? If I go to the application and local storage, right now I don't have any keys or anything set up. But if this goes through, CloudFront will send me the tokens and Amplify will automatically set it at the local store. That's the default option. You can also set it at the cookie store, but we'll use the default. Click confirm. And there you go. You have successfully logged in. And now if I go to application, and you can see the tokens. ID token, access token, and refresh token. So the beauty of Amplify, it will do the refreshing for me. I don't have to worry about doing the refreshing part by myself. Okay. So far, any questions? Okay, we'll move on to the last part of it, which is once now the authentication process is now complete. By the way, I'll quickly show you the cognitive user pool as well. Now I should see a user. If I open it, there we go. I have one user. I go to user pool, open it up, and there we go. I have the user phone number, and the phone number is verified. Now, in user pool, there's this attribute called sub, right? So even if you connect your user pool with external identity providers like Facebook, LinkedIn, or even SAML, you get some unique identifier, and that is specific for the user. And that's the one I'm using actually to do the to identify the user particularly. I'll show you that just a bit, but let's come here and I'll just check out to the next step. Go to step number 5. Okay, right now I'm step number 5, and here we look at it. Now we have the tokens. We need to use that to store the user. So we have to do a few things now, right? Because now we need to create a user database table and the API gateway and the this user registration lambda. We need to configure this stuff. So that's what we are doing with CDK. And then once we define our routes and all that, then we'll use Amplify to forward those requests with the access token, with the ID token, by the way, with the ID token to the API gateway. And API gateway is configured to authorize that user with the cognitive authorizer. So there are a bunch of things happening. So let's have a look. Okay, so I'll start with the CDK stuff. Close out all this. Right now I'm step number 5. So I'll go to my CDK and then go to lib folder cdk.ts. Now guys, this file right now, it's about 160 lines, but usually when you're writing, when you're working on production application, we don't put stuff in the same file. We create like in the lib folder, we'll have resource stacks like, s3.ts, and we have sqs.ts. And we are going to create custom constructs, CDK constructs, and pass in any dependencies that these stuff required. For example, if you have a Lambda function, let's say I have a Lambda stack, lambda.ts. Now this Lambda function probably need to know the DynamoDB table name. So that information needs to pass down to this Lambda function. We'll do that through interfaces. So I'll probably share another repo link with you guys with that also configured. You guys can follow along. But I think this is a small one, so we will stick to this. So here, now we have already done up to this. So now we need to create DynamoDB table, and we are using this level 2 construct called table construct. So when you're configuring DynamoDB, only few things needed, I have already mentioned. User table, this is a logical name, and the partition key. So I'm only using the hash key here. I'll set the hash key as the ID. So this is where I'm using that unique ID I just told you about. In the Cognito, you have a sub, right? So that is unique. So I'm using that as my partition key, and that's a string, right? So I don't have to worry about the hot partitioning stuff. And the billing mode, I'm using the paper request billing mode, and the removal policy, I'm removing it. That means if I delete the stuff, delete this stack CDK destroy, I'm deleting the table itself. So that's that. And then this Lambda function, sorry, this DynamoDB table is consumed by the, it's the Lambda function who's sending the information or the storing the data and retrieving the data, deleting the data, updating the data. All the CRUD operation is handled by this particular Lambda function. And here I'm using this serverless microservice pattern. There are multiple ways we can do this, right? Either I can have one Lambda function for each operation, like creating the stuff, I can have one Lambda function. Deleting the stuff, I can have one Lambda function, and updating, patching, and all that, we can have separate Lambda function. That is like commonly called as a nano function approach, where you have a single responsibility for the Lambda function, so it will do only that. But in a system like this, right, we have not just the user service, right? We have other service. Now in this case also we have vehicle registration. So we have vehicle registration microservice, and probably we have let's say if it's an e-commerce application, we have inventory related services, payment service, and likewise. So if you are going to have like nano functions for each and every one of you, you will end up with easily thousands and thousands of Lambda functions. So that's why I'm using the approach microservice approach, where I will have just one Lambda function per service, right? And there I will use switch statement. There we go. If I go to functions here, now I have another Lambda function called user profile. If you open it up a little bit and go to the handler TS, you will see I only have one Lambda function. It's the handler. And then I'm using a switch statement. I'm switching switching by the HTTP method. If it is a get, I'm invoking this piece of code, right? If it is a post, I'm invoking this piece of code. Put this piece of code, like so, right? So this is again like it again depends. Now, one of the other benefits with this approach is since these are not individual Lambda functions, this Lambda function will receive all the get requests, post requests, put requests, delete requests to this particular Lambda function. Meaning that call starts will be minimal, because whenever it's Lambda function is invoked many times, the call starts will be minimized, because the call start essentially meaning is if a Lambda function is idle, to invoke that one more time after some time, it will take some time, because the Lambda function needs to download this code and then spin up the execution environment. If it is Node.js, you have to have the runtime going on, and there are certain initialization logics. And Lambda function, essentially, these are like containers. It's using micro VM called Firecracker. So it's like quickly spinning up, but still again, in a case of a cold start, it takes some time. But here, when you have like multiple requests coming to the same one, the frequency of this Lambda function getting invoked is a little bit higher than individual Lambda function. And it's not like too many as well, because in that case, we are going to compromise with the single responsibility quite a bit. But everything related to this particular microservice, it will get into this Lambda function. That's why I chose this approach for that. And then we have the logic, like the get request, get the user by ID, and here now this is actually coming through coming after the authorization, right? Now, for example, when we are creating a user in the DynamoDB table, I quickly show you here. Before this Lambda function is invoked, the API gateway will check whether this user is available in the Cognito user pool. It will do this through the Cognito authorizer, and the authorizer will put some context into this Lambda, and that context will contain that sub, the unique ID I told you about, right? So I'm not passing in user IDs, unique IDs from the front end, because if you are passing something from the front end, that is always unreliable. Anyone can pass anything from the front end. But instead, when that user is logged in, automatically there will be authorization process happening here. And there we will enrich that Lambda context with the user pool user sub. That sub is what I'm using as the partition key for the user table. So I take it from the request context, and then that is how I'm actually adding the data into the DynamoDB with the partition key. Yeah, any questions so far? All good? And I'm also adding this condition expression. This is actually really important when you are building decoupled architectures, right? Because when you have multiple connected components, there could be duplicates, because not every service guarantees there's no duplicates. For example, if you think about services like SQSQ, which is a queue service, there's a separate service called FIFO, the first in, first out queue. And that will guarantee there's no duplicate. But the SQS general standard queue, it doesn't guarantee there won't be any duplicates. So that's why it's important to ensure the idempotency of your data, meaning that if one data is already added to the data source, in this case, DynamoDB table, in case of a duplicate, if the same data is again trying to get it added to the database, we have to have some, we have to like prevent it, or dedupe, we call it like deduplication. That's where here in DynamoDB, we have this condition expression, where we'll always check this condition, whether the attribute ID is already existing, meaning that if that item is already added. If it's already added, it will throw an error. So I don't have to worry about duplicates. Also, when you're updating a user, I'm checking whether this attribute exists, because anybody can't update something that is not already there, right? So here I'm using that. So I mean, you can use this stuff, because particularly if you're using a cloud native database like DynamoDB, you can do it by the tool itself, or else you have to have that some code doing the deduplication, right? Idempotency is very important, and it's very hard to achieve, particularly in distributed application architectures, particularly when we have like so many components connected loosely coupled manner. Of course, it's good for the scalability, but there are some other set of challenges that comes up with that. All right. Any questions or anything? All good? I think we are running quite late. I didn't think it will take this much time, but I went ahead explaining that. All right. So I'm going to go ahead and deploy the stuff, and I think you guys can do the same. Let me just double check one more thing. I'll make sure I have the correct package JSON. Not that one. Yeah. All right. I will use the other terminal where I configured my credentials. And deploy. If this works, I'll use the last 30 minutes of our time to discuss about some asynchronous patterns that we can utilize. We'll start that conversation, really. It seems to be a little bit behind the schedules. Yeah. All right. So I think, imagine now this part goes through, right? The next stuff is about user vehicle registration. And that gets a little bit complex. I mean, although the diagram looks a little bit, complex, this actually favoring for the scalability aspects of it. I'll tell you why. And you don't have to like design every systems like a fully decoupled way. Of course, there are sometimes the monolithic Lambda functions make sense. So again, like depending upon your context. But in this context, one of the requirement that we have is the scalability aspects of it, because huge number of users are trying to get registered. And the main bottleneck that we have is this one, which is the the third-party system, or the third-party system that will check the authenticity of the user and his vehicle information. So this is like the bottleneck right now. And if you think about DynamoDB, Lambda, DynamoDB, like I mentioned, like typically, if you think about databases, databases are not as scalable as serverless functions like Lambda functions. If you think about Lambda functions can quickly have so many parallel executions and then flood the database, right? If you think about a relational database like SQL or MySQL, those databases are not as scalable as Lambda function. But particularly for the DynamoDB, it can absorb the request. So that's like that's a pro. One of the good thing that we get with the DynamoDB cloud native database. But still, if you think about this third-party system, this third-party system will fail with that amount of traffic if you directly send it through. Right? That's why let's quickly go over this, and I'll show you some design decisions I made. Right? This is the front end, like everything that we just did here, and we configure it. And the next part is once the user is registered, he's going to register his vehicle. So it's something similar to user registration. You have to you have to enter some information about your vehicle, like a vehicle number, chassis number, the type of the vehicle, whether it's a petrol, the fuel type, the diesel also, likewise. So that information exactly like we stored that user data in the DynamoDB table as well. But we can't use something like this because we need to verify that. Anyone can put any information, right? We could verify that information with the previously because we had Cognito already because user had already signed up, so we could do the verification. But how are we going to verify the vehicle information? It's not available in the Cognito. That's why we need to go through the other approach where once this information is passed down to a Lambda function through API gateway, we will use a couple of patterns. Okay, I'll go step by step, otherwise it's getting quite complex, right? So the first thing what we are going to do is we are storing that data, whatever the user information that user sending through in a DynamoDB table. Why we do that? Now, this is the pattern that we commonly known as storage first pattern. Now, in a complex system like complex though, but there are more complex system than this with so many connected stuff. If you don't store the stuff, store the data, there could be some chance that we will lose that information in any of these steps. Of course, there are ways that we can mitigate it, but sometimes there could be some occasions that we lose the data. And we don't want to lose customer data anyways, because that's the last thing we want to do when you're building a production application. You don't want to lose the data and we can ask the customer to re-enter that. That's why we store first. We can store it in a database like this, or else we can use a queue. These are called, now this is like persistent stores. Now these are not persistent, we call transient store. I can't remember the exact name. It's basically you will store this data for some amount of time. You can configure how long the data will be stored in a SQS queue, in the queue. So you can do that. But there are some services that doesn't support this storage, like SNS. It doesn't like store any data. So that's why we will store the data first, and before working before processing that data. So anytime if something goes wrong, we will still have that original data user entered, so we can work with it. So step number, very one thing you guys have to remember: store the data first, right? If that makes sense. All right, and then we are storing. When you are adding an attribute, this is again a feature that is coming along with a cloud native database, right? And that will really help us to develop application in a scalable manner. When you're adding an item to a database, right, we can configure something called TTL attribute, meaning that I will set an attribute in my payload that we are storing in the DynamoDB. In this case, I have attribute called next refill date. I'll set that next refill date as my TTL attribute, meaning that if I set any timestamp here, let's say I will set this 7 days ahead of today, right? Then after that 7 days passed, when that timestamp hits, this item will be automatically removed from the table. Right? Because, I think if you're Sri Lankan, now we have to, once the full is refilled, once we have the full quota, every week we get a refill, or the reset, the amount of full quota is resetting. And we can do that in multiple ways. I mean, we can run a batch job and do all that. Right? But if you really want to build it for scalability and minimize the cost as well, we can use new patterns like this. We can have a TTL attribute defined there. And once that TTL is expired after 7 days, this item will be removed. And then we can actually capture that item in a DynamoDB stream, because whatever happens with the DynamoDB, item adding, item deleting, updating, it will spit into a stream. Right? So that attribute, when the TTL item is deleted, we can particularly filter those items, the things that got deleted because of the TTL expiration. And then we can have a Lambda function. And then what we can do is we can update that TTL attribute from for next 7 days, right? And then re-add it to the DynamoDB table. Yeah. So the Lambda function is self-sufficient. So whenever the 7 days expired, the TTL will be expired and it will be removed. Lambda function track it, particularly this particular event, and update that TTL value, re-add to the DynamoDB table. So it's like self-managing. Right? So these are approaches, I think, are not particularly for this one. Probably there are some other considerations and all this and that, but I'm just telling you about the common patterns that we typically use in when you're developing asynchronous application architectures, right? All right, and then if it is not a TTL one, right? Still again, DynamoDB is split out into a stream, and the DynamoDB streams are scalable as well. Let's see if I have a question. Yeah, so I think through the SDK, you can define what's the TTL attribute that you are setting up, really. So when you're configuring a DynamoDB table, you have to, ahead of the time, you have to define, okay, this is the TTL attribute that we are going to use. So then, yeah, so you need to define it ahead of the time, table specific. All right. So next, what we're going to do is, let's imagine it's not the TTL delete. And some information now, the vehicle information is added to the database, right? And then it is stored, and the stream, the item will be added to the stream. And then the Lambda function that is listening to the insert items, it will then add it to an event bus. Now, why we do that? Why are we complicating these things? The reason is this. Now, when we have event bridge, now event bridge is an event bus. I think we didn't discuss about it, but essentially, I think you guys will know the basic idea about event bus, right? You can add item to the event bus, and then you can have just like in SNS, where you can publish something to a topic and you have multiple subscribers. If you put something into an event bus, you can configure different targets. Right? Not one target. You can have multiple targets, right? And in that rule, you can write the filter logic. What item should that rule forward it to the target? Now here I have a SQS queue. So whenever the insert item is added, I will enrich that item as well in the stream, because I want to, like, let's say, add another attribute. Okay, this is something newly added, and I put it into an event bridge. I'll write a rule. In the rule, I'll say, okay, go into the message body and then check if that attribute is this value. Right? If so, put it to SQS queue in this queue. So this way I can filter out whatever the interested messages to the downstream services, in this case SQS queue. Now this is really useful when we are innovating this system. Now imagine now this is for the personal vehicle registration, right? Now let's say we want to register some business registered vehicles. So in that case, I want to have a different process. I mean, maybe imagine now there's a separate system I want to verify that with. So it has to go through a different route. So I can add another attribute. Okay, this is a business registration, right? And then add it to an event branch, and I have another SQS queue that will take only those type of message, and it will go through its own processing way. So likewise, it's we are extending the architecture. We are not modifying this Lambda function. We're not modifying this SQS queue. We are only extending it, right? We are open for extension. This is open close principle in architecture level. Okay. Close for modification, but open for extension. So these things are really possible when you have a sort of a centralized event bus. And on top of that, event bridge, we can have some event archives going on. Like we can configure event archive, so we can replay event at any time. So yeah, so that's why we have sort of typically go ahead with the event bridge in an architecture, so we can use it for further innovation. Yeah. However, whenever we are adding some component in between, that's a new hope, right? So there's a latency, little bit latency is getting added. So that is another thing you need to think about. Okay, so the SQS queue, then we'll add it to SQS queue. Why we add it to SQS queue? Because our third-party system is not as scalable as our AWS services. So once the items are added to the SQS queue, we will set a batch size. And here I set it 1, right? I mean, probably we can set it to 5 or so, right? Or 10, I don't know, depending upon this particular system. Then that number of messages will be sent to the Lambda function that is consuming these messages, point-to-point integration. And it will like work with that, let's say if it is 5, the 5 requests will be sent to the RMB and then get the response. And once it get the response, then it will re-add to the event bus, event bridge. Right? You can set another attribute called verification, whether it's succeeded or the fail, and we'll add it back to the event bridge. Okay. So what does that gives us is we can have another rule defined. Okay, whether the verification is failed, right? If the verification, let's say one of the messages got failed to verify, right? In that case, we will have another rule looking at that verification attribute. If it is failed, take it to this Lambda function, and we're directly sending SMS to the user. Hey man, your verification is failed, so please add your proper data, right? And in the meantime, when we are very first time adding the item into the database, we will set this verification automatically for false because that thing is not verified yet, right? You get what I'm going with this right now? So let me imagine now if it is succeeded, what happens? Then I will have another message, another rule pointing to the same event bridge, and it'll check for the verify equal true, right? And then it'll go ahead and do its processing. Now there are a couple of things we can do. This is a sort of a workflow, right? So workflow, we can use step function. But I didn't go ahead with step function in this case because step function is really useful if you have like multiple steps, so many steps that needs to happen in a workflow. But here we don't have too many steps. In that case, we can use another very useful pattern called lambda destination. So if you have one or more subsequent steps to complete, choose lambda destination over step function because one thing is it's less costly because step function anyway they are costly, right? That's one of the highest cost service, particularly the standard step function. The express step function is also there, but that doesn't support the asynchronous invocation. So, however, you can use lambda destination. For example, the item, once it is, let's say, verified true, I will create the QR image. So in this case, I will have the information in this context. For example, I have the vehicle number and and also some user and the vehicle type and so on. So with that information, I'll create a QR image in the image and create the image, and then there are libraries you can use to create that image and store it in a QR S3 bucket, right? Because static images, we put it in S3 bucket. Right? And then once this is succeeded, now you see now these are not straight lines, right? These are asynchronous invocations. That's why I added these as not straight lines, right? If you have asynchronous invocation, you can use Lambda destination, meaning that if there's no any errors in this particular Lambda function, that will again call upon this success Lambda destination, meaning that I can again set up either a Lambda function or a SQSQ or a SMS. There are several services that it supports, not many services has the step function though. So that's why it's again based on your implementation. And here in my case, I just need another Lambda function. So what it does is, if it reaches here, I know that this is successfully stored. Right? I can also create the failure destination as well, right? If it fails, something didn't go right, then I know that didn't go right? Then I can handle it there. So just like through step function, we handle the retry, the fail states. You have 2 steps, not as many steps as in step function, but for simple workflows, we can do that. So if I get here, I know it's properly stored. And then what I will do is I will update that very same database table, because we already persisted that data verification is equal to false. Then I will update it is verified equal to true, because now it is verified. And next quarter date, quarter date, I will set the timestamp from whatever the day it is, 7 days ahead of that. And then I will set the full quota of 50 liters and the QR image URL, because this is also coming down to the Lambda destination. Because when you set up a Lambda destination, you will get all the context, include the payload and all that, into this Lambda, the other Lambda function. Right? So you have the QR image URL, I can put it in the payload, it will be available here. So update that and then update the vehicle table. So next, what happens is, then so then what happens is, once this is updated, right, this update call, again, this entry of item is updated, right? It's not the insert one. Insert one goes directly to event bridge. The update ones, and if that is verification is true, I'll again send a SMS to the user. All right, your thing is now all set. You can go ahead and use your QR code. So I can send SMS to the user. And finally, after 7 days, right, I will get that item will be automatically removed. Now this is scalable at the highest level, because there's no one is going to do a batch job or anything like so, right? The DynamoDB itself is built in a way, just check the TTL. And there's one thing though, when you set a TTL, there's a sensitivity period, right? The TTL is, the sensitivity time of TTL is somewhere, I think, 24 hours or so. But it just happened immediately, but in the documentation, they said about 24 hours, I believe. However, it happens very soon possible, but there could be a time, 24 hours. So make sure that if you're using TTL, if it is time sensitive, there are other approaches, like you have now event-based schedulers, which is highly scalable. You can schedule something on exactly the day, exactly the time you want, which was recently announced. Really good. You can use that service so. Or else you can just stick with DynamoDB streams, because you don't have to pay anything. DynamoDB streams are free. That's the main thing. You can use Kinesis and all that, but you have to pay for it on demand. But DynamoDB streams free. So the cost price is very cost efficient and scalable as well. Right. So here I will select the expired TTL ones, and I have another Lambda, refill Lambda. So essentially what we'll check is, once it is expired means after 7 days, 7 days expire, it has gone. So I will get that Lambda context, and I will set the next quarter date, 7 days ahead of that, and set the full quarter again. And again, I can add another attribute. Okay, this is automatically added. So if I want to make any decisions in the Lambda or something, I have that information. Or in the DynamoDB, I will still have that information. Just for the future proof stuff, I can add that automatically added, and that create that item. And again, when you add that automatic proof, probably I can update this filter pattern. All right, if the item has this automatically true, don't add it, because you don't have to go through the verification thing, because this is something automatically added. Yeah, I think that's it. Right, so let me see how my deployment it goes through. So okay, so I'm not logged in, and I will just start typing my phone number. Get OTP. Okay. I need to update the user pool ID as well. My mistake. So yeah, I think I need to do another redeployment. But let me quickly do it, because that's the fine. But in the meantime, anybody has any question? Any comments or anything that you want to discuss? Index.js. There we go. I didn't think about it when I'm using branching. Okay, I'll update the client as well. Okay, I think this should go through now. I think I updated the CloudFront is fine. Okay. Let's do one more deployment. That's all I have for you guys. If you have anything, let me know. Yeah, so this repo will be available. Yeah, I think you guys, you can go through that leisurely. Vinay, yeah. CDK, well, CDK, there are, I think, if you think about CDK, the main resources I think you have is, this one is really good. So it's basically you can explore it, just like you're exploring CloudFormation and all that. And then you have CDK constructs.dev. Yeah, so the pinpoint, I think, my understanding, you can set up some user journeys and then take actions regarding that. Pinpoint is again like a serverless service, and you can define your user stories, and you can manage your user stories in a very scalable manner. You can run campaigns and so on and so forth. In AWS, it's not just one service is there for one particular thing. So it's again depending upon your use case, right? So if you're using, for example, Pinpoint for a e-commerce web application where, let's say, someone try to get stuff, buys, add it to the cart, but actually didn't check out, right? You can have this abandoned cart, user stories created in Pinpoint, and then take actions. Why didn't you actually check out or go through with your order? So I mean, it's really useful to look at different user flows and see where the customers either drops, and then like have a feedback with them and as to why they actually. So I think that's one of the experience I have, and for that I think Pinpoint really worked nicely, and also I think it has connectivity with all the mobile providers just like SNS. So yeah, I think it's not just one thing in AWS. That's the main thing, because even if you think about EventBridge and SNS, recently a few days ago in the reInvent, they announced this payload-based filtration in SNS as well, which is like really useful, and that's one of the good reason why we sort of use EventBridge instead of SNS, but now it's not there. But again, EventBridge has its own features like event archiving stuff and all that. which is not there in SNS. So it really depends on, we can't actually pinpoint, okay, this is the service you have to use. You have to like look at the use case that you're building and then make the decisions accordingly, I think. Yeah, I think it's deployed. Let's see one more time. If it is not working, I will just anyway abandon it because 1 p.m. already, 30 minutes late. All right. So, when I refresh it, the stuff like the previous tokens were there. So Amplify automatically like identified me as already logged in because this access token is valid for ID token and access token valid for 1 hour. I think in 1 hour didn't pass. That's why it just got me logged in. That's one of the really cool things. But let me see. I'll just add the 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. Address something 1/15. And then I save it. Oh. Yeah, I need to update the API endpoint. Yeah, so it's this part I didn't do. So you guys can do it. So it's basically you need to update the front end with API. Amplify configure, we previously configured auth, but now we need to configure the API, and you can get the API endpoint, which you get here. This is the API endpoint that that the API gateway is using. This one. Where was it? Here, user registration. This API gateway endpoint, because I couldn't update it in the front end. I forgot about it. So update that and then do the redeployment. Then you will find that information is available in the DynamoDB table. I'll leave it up to you guys. So that's it for today. And that's all I have for you guys. But thank you for joining. See you guys. Bye.